Okay, so it was that was the big push for operational oceanography because there was a devastating accident. And then, and also we were almost ready to go. And then at that time, the EMSA was not ready to undertake that. They built an office where they have people that now, on request of the member states, activate the oil spill modeling. So it is our strategy in Italy was with the Coast Guards, because Coast Guards are the one in charge of going. And for many, many years we worked with them, but at the end they failed, we failed, actually I should say we failed, to keep the upgrading of the system while for many, many years, because we did this a long time ago. And then we had upgrades and stuff, but we weren't going back to them to do this. So we are trying another strategy now in Italy, which is that we have a national system now for emergency response. And we are in as the one that are responsible for getting the models always updated. So we receive money to get the models up to the point. As it's not much, but it's enough to make a consolidated and institutional commitment. So Europe has EMSA, but EMSA is much more than that. The EMSA is the one that gives you the satellite images. Yeah. So that's the main part of their budget, and it gives it on secure network, so that it is one of the secure networks that we have. So even if the whole, I don't know what, goes down, that information can arrive. Yeah, there are many aspects.
I think that Brendan brought an interesting point, because it's not just the setting up of such a system. We have to convince our high level and finance institutions for the maintenance of
the maintenance, absolutely.
So yes, we are there, they install it and they think that's it. And it's not like that. So it's really difficult. And you know that we had a horrible experience here in Brazil in 2019. We had a major oil spill accident reaching thousands of, well, not thousands, hundreds of cities off the Dominican coast. And what we found.
We didn't do it. Some days we didn't do your ones there.
Yeah, well, we asked for help for the agency, and we got lots of help from Copernicus.
Exactly.
They helped a lot. So I think that cooperation is essential.
Essential.
For that kind of hazard getting to our coasts, because in such cases, like an oil spill like we had, it's going to be a decade, 10 plus years to recover back, if at all, to the original state. So the concept of coastal resilience all the way down to 6, so we probably won't recover to the original stage of what we had. So I think that it was a great example of how cooperation
International
makes a difference.
I would say
in that case. And this is important for all of us here in this room to understand that and seek ways to reinforce this concept.
Yeah.
Because in some cases, and I've seen that happening in our country here in Brazil, mitigation is more important than prevention. Why? Because it gives a better reputation to politicians to say that they have influenced the recovery. So you have more flashlights on the mitigation than on the prevention. That's the true fact.
Well, the mitigation is the one that they can actually support better than the prevention.
So hand in hand, we have to change the game.
Yes.
You
I
have to.
think it is, yeah, and you are the one that have to carry the word farther out. And, but now you have the tools.
Mhm.
I mean, 5 years, Copernicus became operational in 2014. So it is 11 years. Before that, it was not possible.
Yeah.
I can tell you it was not possible. We did the special cases, this and that, and the institute over here, the institute there. But now we have you have to have a Brazilian system, you have to have an European system, you have to have, because it's a lot of, because there is a lot of knowledge to share.
Yeah.
And then what happens? Yeah, so we were lucky.
Ready for coffee or?
Thank you.
I can hear Francisco.
So Francis, you can show the prestige, right?
Sì, ma non sono così spesso.
Não tem nada direito ainda.
Okay. Okay, so you choose to Shine and you have to download the image of Shine. You have a Windows Center. Okay. So, okay, so let's check the other. Because actually we can share at lunchtime one that has already downloaded the image. We can share through the USB key.
So why don't we organize that now, not on lunchtime? It's better, and now we know who has a Shine. Hyphen code, Docker.
Docker image codes. So, you?
Okay, I downloaded the link, the file,
Okay.
into the virtual box.
This is the virtual box.
This is the virtual box.
So she's trying to install the virtual box.
Okay. It's working?
It's working.
Okay. So now after this installation, you just need to import the virtual box image of course, and then inside you can use the code, the image code.
Okay.
So you need the Docker the virtual box image also.
Okay. So after installing the.
Yeah, because Guido he has already, so it's also 6 giga. It's better that you take from Guido.
Okay.
Okay.
So why don't we take it from here?
Okay. So who has a pen drive? Just a way to.
It's all okay.
Yes. Can we use to pass the image?
No, but ask Fernando. Fernando.
Fernando, pen drive, temos.
Yeah, we have a pen drive. This one. Show it to Fernando. We want to use it.
Yeah, we can have two pen drives, so
It's
it's
going
it
to be a
up.
very big pen drive, so it has to be a very big
Yeah,
pen drive.
big pen drive.
One more.
So.
So now in this pen drive, I will put the virtual box.
So can you tell me how big is the pen drive?
It should be
Can you put the virtual box image?
Yes.
Oh, this is so nice. Let's take a look at this one.
It's already. Yes.
So if you have a few, now okay.
Whatever you said.
Tem dois? It's here. Rodrigo, não pegou delas por você. Aí vai passar isso. Fernando José trouxe pen drive.
Yeah, copy it.
So now,
Eu.
okay, so now, okay. No, but I have to download this. Now, if you go
install download the image inside the virtual box. After we can transfer from your computer to the inside the virtual machine, you can add something to the file that's on this level. You're copying an image to your hard disk.
okay, now we just I don't know where they are. Which way? This one?
Francesco, you have to get the pen drive.
I don't know, this is.
Peter, you have to wait. We need to have the pen drive. Yeah, Francesco.
Tá precisando, Fernando, tá precisando de outros pendrives ou não? Não? Ok.
Any more flash drives? I can.
We are fine.
Okay.
Thank you.
Okay. This one is a file. It's a file. This file, I don't know what. This one. So you have a file. So just we put everything in one or a couple of drive, the virtual machine image and the document image. Sorry, share together. Okay. So just that's I see. I see.
Francesco, wait.
Okay. And also do okay. Perfect.
In the version?
I see.
Atmospheric ones.
Yes.
Yeah. There is the hard disk.
Yeah.
This is the.
Our image are feeling.
Yeah.
And when we try to copy the image on the pen drive, we have to have
It's the one
we have an external hard drive, like
You could say.
perhaps so
also when you're back.
the storage capacity, right? Because of the media. You have an external.
We have W.
And the size of the file itself.
I was playing to calculate with the old.
It should.
Running. Because we don't have the traffic. Yeah.
Hello everyone.
So then.
Hello.
Hello.
Yeah.
Yeah. Quick question because I'm seeing Surf Nemo displaying on the screen. I don't know if I have to download that too because I already downloaded Surf Shyfan first.
No, it's okay.
Yeah.
It's okay. That was the lecture. The first lecture would be on Surf Nemo, and the second on Surf Shyfan.
Oh, okay, but are we gonna do anything practical on Surf Nemo?
Yeah, you can do later, but if you want to start with Surfshaven, it's enough for today. Actually,
More than enough
more than
for
enough.
today. Yeah.
Only you can download the Surf Nemo and try the second exercise. Okay.
Okay, no problem. I think I'll just download Surf Nemo.
Let's
Then.
try to get one of them working. One of them.
No,
Okay. So when we try to do this image here, so this is the it's
Actually, hey everyone. Which exercise did you choose yesterday? No, I free.
I need to copy the
And if we
But it's a micro scale of what would it take?
And it's not a matter of space, right? So you have enough space.
who has Windows and is going to the sort Nemo? Okay, that's I have.
Yes. Okay, so that's why you need an external drive. Okay,
I'm downloading. And I copy the link. So here you are in the virtual.
Okay, so I think that when we will have the two images in an external hard disk, they will be very fast to because
We have to wait.
someone has some each and someone has another.
Oh, we have to.
Who is already ready for the exercise? You? Just you.
I'm having trouble using Linux on the virtual machine.
Why don't you go while you wait?
Yes.
You're waiting for the large pen drive?
You can't copy.
Always find out. This time I didn't take that.
It's the conversion for the virtual machine. I think I need those
This is the wrong one.
It's just operational system. To run the games that we relate to this. We are putting the whole images in a hard disk and then we pass and copy for the hard disk.
Hablando, send us.
I mean, why don't you finish it? I have the hard disk.
No, because you have.
So, you have downloaded also the virtual machine. And you also, you use a Surfshark.
Okay, does it updated?
Because you already tried with chicken, right?
Yes, and we have another type of
Yeah,
Okay, let's try.
I think.
Yeah, yeah. Virtual piano. No.
Where is the pen?
Ah.
They have not the drive on
Yeah.
Who else has served you
Problems like
and has a Windows?
problems for
Ah,
I cannot the one.
format.
Yeah. But people already tried other. Have another small, just to check if you can send something smaller.
The freedom machine, for example.
Yeah. Yeah. I think that's something not address the size, you know.
Meaning like that, so all the students or
I don't need the format of this. Okay, just see it as.
Conseguir drive externo.
eles não são na pendrive, pode a gente vê depois
Yeah, okay. Okay. If I I can copy to Oh, you have, okay. Yeah, because it's this one.
Posso levar um pouquinho, posso fazer um Sim, a virtual machine é ok. É o código que
So, still waiting, are you waiting? No? I sent you the pictures, that's for the download? Yeah, I have external hard drive, so. Okay, no problem. Already. Hard drive. We have. Okay. Forgot about it. Okay. You need more or should I?
First two. Yes.
Okay. So maybe we can someone follow up and try another computer that
Ready? To transfer.
yeah. I remember.
In 1 minute.
Yeah, okay, this week. Yes, and we have another one for type.
I've already.
Yes,
Yeah.
so I think we're gonna be covered. It's much better.
I don't know if you know how to make it working inside the widget.
Work fine. Okay. But you, after that, when you're on the digital machine, you have to find more less high.
Yeah, I right now, but I want to see it later.
Please, let's finish the downstairs.
No, not, I don't know, Chapin. Okay, Chapin, okay.
Now I am with you.
So you did like an external drive, and she's working, she's helping the others.
Yeah.
So we need to already show.
Você tem que para botar o prédio em pé, estabelecer a sala, toda a área de infra. Tem.
No, don't do it that way, don't do it that way.
Okay,
Not
okay,
downloading.
okay.
I don't have if this is your solution. I don't have any. Você vai rodar Sim. Você vai rodar ele aqui mesmo, terminal ou no vídeo? No terminal. Posso esquecer o se não você tem uma facilidade.
I never worked by yeah.
Mas quando
Seja.
Now, we have to wait for the we have one more hour.
But I don't think so.
In 20 minutes.
I need to talk more.
There is
I'll be with you all day.
Oh, so
Does anyone need all of the virtual machine observed? I will need the virtual machine observed. There is here.
Yes.
you know, so.
No, not yet.
Did I just give you or I lost?
I see it.
No.
Yeah, see. So you have the image. Now actually,
How do you have a laptop?
just it's also the
So why don't you take it out for,
Yeah, so let's put your image in a drive to share screen, but
Like the same one?
you have a Windows, this is Windows? Because you have a big one, but only for, that is formatted for Windows.
Virtual machine. Sim, porque eu tenho a do Docker. Ok.
But you know, we are not.
It's right. But this one.
Can you check the phone?
No.
Well, why don't you set it up? Okay. Maybe you're
That you are going to share with your
You love the vehicle.
Oh, so we have the different. Surf. I surf. Okay, surf. Okay. So, yes. So I now inside you have downloaded the shy fact. Yes, yes. Do you know that the senior? And it's also the person was so is in the documentation. Ah, I love it.
I panicked for.
Yes.
Right.
So
We're almost here, right? So where are you? 20% about?
35. 37.
Oh, you're doing very fast. Are you using the internet here or your own? Oh, you have a help. Ah, good. So you get the connected one.
Yes.
You don't want to see. You don't want to see.
Then I should look at it.
Yeah. So you are a Windows user, right? So you can use the.
It's finished.
Finish the download your surf Nemo.
No, shy. No, no, she's the first one that loaded the image inside the desktop. So it's ready to run the simulation now. Okay, so one.
No, but wait a minute, can't we bring her to the other computer?
No, but right Linux operating system.
You can create a folder.
It has all Windows.
You just need
The other day, download the install box.
So the solution of this, unfortunately, this course came a bit too early, but the solution that we use a cloud. In cloud, you use a username and password, you use a web driver, a web browser. And then you have it. No downloading of any kind. So, but we were short a few months.
That's why you.
So we global.
And to mount.
Italy, the cloud, no, the cloud is European, it's an European, and we have reserved space, but for millions of people to connect.
Yes.
That's the way. We have the end of the project by December, so.
No, the terminal.
So after you get some practice here, I don't know if you want, because you have a good computer, so.
Yeah, okay, so.
What is the document? What? Of what? No, I agree, but which program?
So now I know.
I don't think we subscribe that. Yes, I'm a doctor, an image. It's just a writer. No, it's a bad one. It's a bad guy. It's a bad guy. It's a bad guy. Many people get confused, no? Exactly.
Like what is dogs or what is shirts?
Exactly. So you shouldn't use
Yeah, so somewhere it does. Expands all the lives.
the doctor is there. I know.
It's like the environment in heights.
Zero.
No.
It's years. I want the model. I want the model that was years about the library.
So I now understand.
It's like basically
So I imagine there is environment of five.
The environment is anaconda.
Not just
Who cares? It's more.
Sharon is
No, I think this is really.
Now you are downloading inside the so it's like you're Europe food. Now the code that actually is medical codes with some interfaces, icon and so on to get data profile that you will see. So it's the real part, important part is the surface effect. So it is, and all the rest is a bit complicated because you have to create the environment. And Python works. You have to have all the rest. Constructing. Now we are constructing a lot of computers. Before we were logging in. And then writing the code. Now it's not possible. We have to take time to see what is needed. So I'm happy if you learned that there is an interface. Because the interface, the operational system is important to know in general. Yes. Not too much details. I don't like the image Docker wording. But yes, something that. What are we doing?
We are waiting downloading almost finished on the copies.
Which downloading of who?
Surf shaping.
We have already
Search
Surfshark here.
Yeah, but with Linux, you know.
Oh, sorry. Oh, sorry. Everybody has
Windows.
Windows, okay. So where did you get the Surfshark for Windows hard drive?
If you have downloaded it, it's finishing in 15, 20 minutes.
You see, this is smart guy. Smart guy connected himself to the internet in this way, so he is the fastest. Also, very nice, smart girl. Yeah. So, and are you downloading something?
It's the Sharpen.
Also.
That's gonna be.
Yes, a hard drive we need that.
You will need to free space in your computer to do that.
Zero.
Like freeze up the copy.
Yeah,
That's
Fine.
not,
yes, it's not so easy to do.
you have to delete lot of
Clean
stuff.
up. Yeah.
Do you have like?
Check if you can do it. If you cannot do it, let me.
Or use from the drum.
Yeah. And nothing much, yeah, just like 18.
I mean, this is the central.
Yeah.
You have Linux in your no, it's back.
So you are downloading somebody else.
You have the same.
Can you see it again? See what you
Yeah,
Let's just display that.
First questions.
Aí ele deu
Okay, but we can read it, right? I can't really read it all. So,
and this, the local ones, he has like slides, as the in-house one does.
Existe de bota
external.
Só que ele tá mandando isso chegar.
The external. Where is the external? Sorry, the external that is.
Yeah, all of your processing.
We don't have any secret.
Then you love
So, anything that's not downloading on this,
Só que ele tá aqui no Linux, tá?
the E, and you should download the C. Because if you're spacing the C, I don't know how much, before you have an image. When somebody finishes Surfshark,
Yeah, here I think should be the first.
okay, how about Surf Nemo?
Okay.
Who has downloaded and working?
Surfnemo is already copied, no? It's really, you already made four captions of Surfnemo.
So why not just speaker now? The others, so try to get the other Surf Nemo. Who uses Surf Nemo? You use a Surf Nemo? And what do you do? What are you doing? From yours?
Yeah.
Fantastic. Okay.
It takes only 2 dollars from the website. She already has some benefits.
And you made already Surf Nemo working on the virtual? Which image now? the virtual machine. So what is your computer? Is it it's Windows. So you need to download the virtual machine. And did you start it?
No, I didn't.
Why don't you start the Windows?
Everything is here, so I just.
That's the.
All you
My
have
virtual machine is. Yeah, it's gonna.
Take this.
we told you.
You learn both.
Can she work with the virtual machine?
Just the, that was the first machine.
Yes. Fair enough. Yeah. That's what I wanted to tell. So you have to prove.
Yeah, I have changed this one.
No, you can't. That's what we are. You cannot use the virtual machine from the hard disk. From this one. It's
But I already, I have used the virtual machine.
That's right. Try to use it now. No, it is already.
No, I have to use the virtual machine, but
No, you need to use our.
yeah, first of all, my computer
And then, then you from there.
Why don't you do it?
I was kind of like you guys. And if we learn all to each
yeah. I can't use
So why don't you actually?
This is really, what's up?
Power.
So that should finish it. Okay, my.
When did that start? And then you're going to put this number.
And then I go to this.
Actually, no,
How about she has this? So why is it? You're still waiting for the. Yeah, fine. Let's see.
I wish you were me. You wish it was you. How would you know? What you're seeing?
almost there.
Where do you go?
We have 8 hours.
You need to finish the side things.
Earlier it was 9, now it's 8.
Now, then I show you the internet cable. Cable?
Cable.
Yes. I'm after you.
you learn English.
School.
No, I've been speaking English.
Why does it take two?
No, it's just like how I was. Yeah. My mom knows me. They're both Moroccan.
Exactly. Is there, and that's why it takes so long. That's what I mean.
No, but now it's open and then it's copy.
When I was like,
See my. That doesn't work.
then I saw, maybe I was watching a lot of
It is, it should be residing
growing up.
on the hard disk of your computer.
Yeah, but I don't have space. So I just.
Fluent to your.
Yeah, I think that my brother too, it's not very many years ago. So that's 15. No, what?
50.
Well, if he's 50, how old is my parents?
This thing is more English than how do you say? Tradition. Tradition.
No, no, before everything.
Wait, why
See, I tell you, I don't know if I'm wrong. See, then I tell the boyfriend, I just swear. No, man. I do want to finish. Yeah.
Oh, yes. Here's everything.
Yeah, I have.
I know these guys. So how much space do you have in your hard disk computer? There's no. Okay. Well, what is the situation now? You,
Yeah, I will open here, the center, in the virtual box.
okay. So you have the virtual box, you have Surfer,
Yes,
code inside to be,
I have this too.
yeah, exactly. Very nice.
These I just lost.
So you need a human to action it.
Okay. I will. I wish so.
Where are you now? Say that one.
No, it's download.
No,
Copy,
no,
copy,
yeah,
Yeah, once that is done, yours, not so time. So, it's basically.
Okay, where is the virtual machine?
No. Try it.
You say what are you now
This is
copying?
Nemo. Yes.
Okay, so you're doing that. But you haven't done that.
One, yes.
It's good. So, how are you doing?
I need you for the image.
Yes? So are you copying from where? Well, from this which you don't have. So what do you have copied in your computer? Yeah.
I would be if I just.
Yes,
So what does she have in her computer?
the code she doesn't have yet. She picked the search.
No, so she has nothing.
She has the virtual machine. That's the virtual
She
machine.
has a virtual machine, okay. And then
All set. And now
what's that is that one will take half an hour or 3 hours. 3 hours with the cable, it's nice cable. And the connection, 3 hours to
Yes, I
copy,
know.
3 hours to copy. No, because of the hard
I
disk.
have this one here, but I have to go inside.
No.
No.
We just need to, that folder we are going to share with the virtual machine, so that you can see it from the virtual machine. That's it for you.
Okay, so.
That one is okay.
So what don't you do? So she doesn't need a copy?
No.
Okay, so what don't you do? The copying is impossible.
Tá aberto, a gente vai ter que desligar ela.
Para isso, né, beleza? Você tá baixando aqui, entendeu?
Sim, acho que pode puxar ele.
Okay, what you have here?
I think it was, I forgot to use it is a shaking.
Since the generation is 4,000 and share folders, which choose the folder where your images. This folder.
Sliding.
Very
That is to start.
Yeah.
Not you have to just use this to bring it.
No, no, just, okay.
Yeah, I have not
switch it off to change the settings. We're going to do it after together. The images in our computer in the host system. Now we created a bridge between the guest and the host so that we can load. Basically, Surf Nemo. Anyone else needs to copy the code Surf Nemo
Nobody? So we are done?
virtual machine.
Are we, do you need the Surf Nemo or Surf Shark?
She has a problem with this space.
Oh, but you have problem with the space. You free?
Yeah.
Okay, Surf Shark.
Okay.
So let's take the hard disk.
Okay, amazing. So these are seen inside the virtual machine.
Yes.
Okay. From command line, we have to open a terminal. Okay.
To finish.
We are going to say Docker load this image. It means make it available for my system.
So why don't you type it?
Myself.
Yeah. Because nobody knows, no.
How you can put this slash?
Nemo.
Nemo.
Okay, wait,
There isn't yet. It's
you mean 2 minutes and then
so let me see. Yours it should be here. So it's video.
Can you see in this region? Okay, then that's right. One Google Docs, one OTA,
And the one Oracle.
Yes.
Yeah, the name was here, no.
I don't know.
So why don't you see it? Go to see it with her computer.
I think you need one.
Okay. No, but I just downloaded several things there.
Yeah,
Yeah, and then I'm
Offer.
Now it's open.
Image.
Yeah, good. So who is it, knows that?
No, but you're,
Who knows that?
you're going to do the tutorial, all the windows together, doing.
No. So.
Okay, so now you're going to take 4 or 5 minutes.
No, I don't think so. See, you want to ask them the five minutes. Because it is there. Yes.
It's there. Yeah.
Yeah, I don't have like space.
It's very
How long is that?
unexpected and
Is that unexpected? Unexpected, so I think that because already they have to.
I think so. So if you try to copy, say copy exactly.
Mas eu pedi pra criar, a imagem sair pra cá.
Not perfect. Very good. Now I thought it's fantastic. I thought this so it is so I think that now you begin. Yeah. How it's. It will be. You change. You will exchange. Well, perhaps so you change yes. It is also
And I agree. It's not.
It's not the point of the right.
It's not the
I
now
here. It's as possible.
Can you try to get
the sharing of control.
Não é porque ele tá.
But these are the small ones.
Não é?
yes.
Can you get some help?
It's just
Downloading something.
you know,
like to download it, but I copy and paste the code and it's just
to text. I was
it's step 3. Yes.
you just much so this is yeah, and it's a stuff. So, but just to see if now you have what the application is, then you check give it on table. And then
Can you move some file from partitions? Yes.
It's faster. If you need to stay
With them.
And
You
you,
finish?
I'm speech. Almost.
You finish the download?
Yeah.
I type the line, I go.
Is the virtual machine. Just my information. No, yeah, it's a really more sign up. Just
So. So you can create.
No, I know my not because I did. But actually, no, actually,
I've never seen this.
If you are seeing here, but I think that now they are starting to change all the operational systems.
But you can work with it. You can work with Thank you so much.
Era assim.
Eu acho que
Aqui, ó, a Angelica não.
E loro adesso
Ok, facciamolo, però fallo molto breve, perché è già l'una 12:04, possiamo dire di fermare questo. Non fanno pronto, niente. No, no, lei non riesce ad usare perché ha il computer pieno. Okay, so we decided that we need to stop now, listen to Francesco, so that he will show you what you should do with the Surf Nemo. And we go to lunch, and we come back, and we try to see where we are. Okay, so I think that, you know, your computers do whatever they can, but when it is too much, it's too much. And this is a lesson that we are learning. that this is not a feasible way and that the cloud system will be the way. But we will try to have as many of you arriving at the right level, okay? So
if, for example, just 50% succeed, then we just put a couple and we work together. So let's present a little bit this package, this demo package. So I will give you an overview.
Excuse me? Okay.
Because of the
yeah.
And then Rodrigo perhaps also we can do late after lunch the shuttle part. So if we can take time now, that's so an overview, so we'll start with a motivation behind the local topology modeling. Then I will just point out the importance of model resolution. A few slides, some basic concepts that Livia and Luis already told yesterday, but just few concepts that is important for scaling. Then I will introduce the SourceNemo platform, and then I will show the results of the downscale experiment that we got here. So, as another thing, the global regional operational forecasting system are very useful, but the idea that we have to begin is how we can get a resolution on demand simulation tailored to any shelf and coastal area, wherever needs emerging. So this is the idea of and we know that across the globe there are many regions that are increasing impact from by challenging, including climate change, like pollution, and so on. And one common needs across all these situations is to have a good quality field, so a high resolution ocean field. They can be crucial for some situations. They can, for example, enhance maritime navigation. They can support a better emergency response for extreme events. They can reduce risk in coastal areas or spill, and so on, for many applications. So, we know that we have operational forecasting services like CINEMS that in the last 10 years then have made the ocean analysis forecasting more accessible. So they provide a global and regional product. The global one is at 112 degrees, so more or less 10 kilometers latitude. And there are regional products, this one on the map, that its solution at from 116 to 114 degree resolution. So with the global, you can capture the large diffusion, and with the regional, you can capture more complex mesoscale structure, and they can add value for shelf application. But the limitation that the CINEMS products are not optimized for very high resolution, for cost application. So the idea is to have a more flexible and adaptable solution to generate forecast. So what we need a way to quickly deploy a resolution model in any region. And Surf is designed for that. So Surf is an open source platform designed to set up, to facilitate users to set up, execute, and analyze a resolution next in ocean model in the for the world. We integrate in the platform two state-of-the-art ocean models. So NEMO is a structural grid-defined different model tailored for open and open ocean and shelf application, and the Sharp MPI an extraction grid finite element model designed for complex causal dynamics. It uses dynamic lambda scale one-way nesting to generate a resolution nesting model, and is, as you see, is distributed as a container, and also we have also virtual machine that can be helpful in this situation where you cannot directly use the container. That are portable visualization technology. So are very easy to deploy across different computational environments from local machine to cloud. And we are implementing this platform in many areas of the world, validating and showing the better performance of high resolution compared to the parent cost resolution model. Now, just a few concepts about the impact of model resolution. So, we know that the ocean state evolve over time according to fundamental dynamical law that are expressed by the system of partial differential equations that are a mathematical representation of the three principles: conservation of mass, momentum, and energy. So, if we write in a compact way this system, we can, so this one is a compact way to write the system of partial differential equation. So we introduce an ocean state variable that describes the ocean, so density, velocity, pressure, temperature, salinity. And what this equation does, they can predict the future state, so in the future, based on the initial state and boundary conditions. So we have a time derivative of this ocean state vector, and we have an advection term, and then we have a forcing that tell you how our state variable will evolve in time. But as yesterday we showed, numerical we cannot solve partial differential equation. There is this non-linear nature of the system that make this problem that we have to solve, and we use numerical technique. So we are moving from a continuous problem to a discrete problem. So we instead of solve the partial differential equation, we solve the system of algebraic equation. So what we are doing, we are trying to compute with the numerical technique a solution. We define a numerical grid, and we represent variable and derivative in that grid. In the end, we will find the solution, a numerical solution that we want to be a good representation of the theoretical solution. So now, one most important concept that we need to know when we do downscaling is the concept that our model, numerical model, we have resolved physics and unresolved physics. So when we define a grid resolution, we know that we can explicitly resolve scales that are larger than effective grid resolution. Okay. And then we have computational constraint. We cannot define like small, like millimeters. So we have a computational constraint. And do this limitation in numerical model distribution between resolve and resolve physics. So resolve physics we represent the physical process that that model can simulate based on the grid resolution in numerical framework. And then we have unresolved physics that include all the sub-grid scale processes that are smaller than our grid resolution that cannot be resolved and need to be parameterized. So there are model, some physical model that they will tell you in some way what happened inside the grid resolution. For example, in this case, this sketch, you have this structure that are resolved because are bigger than effective grid resolution, but this one cannot be resolved, so I parameterize. So for that, spatial resolution is crucial to represent simulation motion processes. Because if we increase resolution, we go from this low resolution to this high resolution, we can better, especially resolve more scale, also smaller one. One you parameterize, here you especially resolve the structure. So you are able to capture a broader spectrum of ocean turbulence. And you are reducing, if well configured, you are reducing this, the uncertainty of the sub-grid scale parameterization. Okay. So this is why it's important to go to better resolution. One, because you can better represent, for example, all the topology, bathymetry, post-dynamic, but also because you are explicitly resolve more scale and reduce the need and the parameter of the parameters. Now, let's see our source work. I will focus on source Nemo. So these are the workflow. So there is a user configuration file that we will deal this afternoon that define parameters for all the workflow phase, pre-process, simulation, post-processing, and then automatically the system will prepare all the input data required for the ocean model. So it will generate the grid, bathymetry, all the atmospheric forces. Then after that, the simulation will start on Nemo. And after the simulation complete, there will be some step of post-processing. So we will see better in the example, but we have we choose as a data structure a JSON format. It's very typical for web application JSON format. It's very simple to understand that we have 9 sections that define all the parameters needed for pre-processing, simulation. We will still get this after.
Also, we hope we don't have to change them from the standard, right? At the beginning,
From the standard.
from what you run in your simulation with. So when you download, you get already parameters set. You don't need to change.
Yeah, now we will give you one configuration file for this downscale. So you don't need to change nothing. If you want later, we can do another experiment. But in this configuration file,
Everything has been chosen for you.
preset for you, and like domain, the time step, and so on. Okay. Then all the pre-processing, the system automatically will download input data from a server repository. We normally use now in the current version, we have Jellicoe bathymetry for the bathymetry. We initialize for forcing initial condition and boundary condition, use product from Chinenzo that you can select from the list that are automatically downloaded. From atmospheric forcing, you can select ERA 5 and then set product. We will use ERA 5 this afternoon. And the teller forcing to correct the velocity at boundary, we are using TPXO 8. And so on. So the system, after you start, they will take the data needed that you select. They will generate a grid, so remarkable bathymetry. If you want also manipulate, generate a mesh mask of your domain, of your 3-dimensional domain. You use that for create all the file needed for the ocean model, so initial condition, lateral boundary condition, atmospheric forcing, and here the oops, and also there is reader and reader. Okay.
So I have a question.
Yeah.
So now in this version of SURF, the coastline bathymetry is already inside. It doesn't need to be downloaded.
No, okay. Yeah, we have, you can choose to download or to take offline. We will give you the input file disaster, so just cut it in the area that we will simulate, and we will point at that location inside your computer. We will not download nothing, because there is an option to take from.
So it is easy to download, but we don't like downloading.
So, but if you
We
want
are
to
seeing
change.
the problems in downloading. So we have already downloaded.
Yeah, we download for you, so you just take and you, if you want to change region, okay, you activate the downloading, so you will download directly to yourself. And then after that, so everything is ready for the ocean model, input the configuration file, the name list, and so on. They will use, and the simulation will start. We will do 8-day simulation using the new ocean model. Then they will give us the output, file, an XDF file that contain all the prognostic also the diagnostic variables. And then some tasks from differentiation and analysis for checking the accuracy. And just to recap what also yesterday was saying, so we know there are different, each ocean molecule has a different way to discretize different discretization method, grid structure shape, how the variables are arranged on the grid, and vertical coordinate system. The NEMO, following this, is using 5 different methods, so all the calculations done on points. Okay, is using a structured grid. In particular, we use a simple lateral grid, a regular lateral grid. As a variable arrangement is using RKC, okay, and as a vertical coordinate system, we are using a zeta coordinate, actually zeta star coordinate. So zeta star means that the vertical location of levels will follow the SSH. So will change in time. Okay. Bien, so next, also you can find information on the platform at our website. Checking, you will find how to download all the image source code. You will find tutorials that you need to update with your version, and you will find documentation with all instructions to installation and checking how to do different kind of experiments and so on, and all a bit of basic concept of the system. Okay, so just a few words about this case study. We will do a downscale experiment in the Southeast Brazil and Costa region. It is Santos Basin. Okay. We will perform a downscaling starting from CHMEMS, global unfair forecast around 12, and we downscale to 3 kilometers, so 3 duration 3. These are the area. Okay. And the simulation period we will run a day, so starting from 21 of August up to 29, so 2 weeks ago.
Sorry, the choice is due to the ERA 5.
Yeah.
Because ERA 5 does not give you the forecast. So they give you only the atmospheric forcing in the past. So we have done a past that is near the present, but is not a forecast, right? So again, if you need a forecast, you need to put atmospheric forcing, forecast atmospheric forcing. And to do so, in Surf Nemo,
Now
you can use
now there is just
NSAT.
the option on NSAT. First resolution NSAT that are open and free, so 0.25 degree hourly.
But ECMWF is not open and free.
I think it's
Don't you have any global projects from ECMWF that is already free
No,
for the whole?
for forecast, no.
For
I'm
forecast,
sorry, no.
for, ERA 5, no?
Era 5 is a reanalysis.
Okay.
You can have analysis, which are 0.1 degrees, but I'm sorry to say that European Center for Medium Range Weather Forecast is a public institution, still does not have an open and free policy for forecast. And you have to face this always. You will face this every time you try to do the ocean. Okay, so.
So just to check visually the grid, just if you just try. So this one already is the global forestry solution grid.
So this is Siemens grid.
This grid is 9 kilometers. You cannot represent well of the coast.
Yeah, but they never seen it. Just stop because it's nice to see the grids.
Yeah.
This is the global grid created every day by Siemens with fields and everything, right? That this is marine. So Siemens, we call it, it's the Copernicus Marine Environment Service.
Whereas this product has initial condition and boundary conditions. So this is the resolution. And for this downscaling, so we are going from this grid to this grid. That is also not enough to well resolve
Come
actually.
on, make it large.
Right, just
Thank you.
take some time. Okay. No, the other reaction, so it's the opposite from my computer. Yeah, for example, here
So you see,
you can
the points that have been added for the downscaling, right?
Yeah. And so we are triplicate the number of points respect to time. So we are increase the resolution and better, little bit better capture.
Not enough.
Not
here.
enough, for example. For
1 point. So when it was a Siemens, it was by chance, there was 1 point here. No currents, nothing. So it would have been no truth.
Yeah.
And then now we have 2, so still not enough.
Still not enough.
This is not enough to get this, right?
Now,
Go there, go.
also if we go to our Rio is actually now our shores of the mesh mask is also we will have some connection in the open, but it's still a few points cannot resolve very well the structure inside.
We can see, there are very few points.
And so the option is do another cascading. So we start cements to first cascading and then a second cascading as Luis showed yesterday in the application. We are doing multiple cascading, or we can use this initial model. I will do this as input bundle. Okay, let's continue. So this is the grid, and as bathymetry, we are using bathymetry. So this area has a narrow bathymetric shelf with a very short gradient in this area and very complex line with Day Island that will generate complex circulation patterns. Actually, the one is a better representation find online. So here is the bathymetry of this area. You can see very narrow and gradient bathymetry. So we go from a shallow that is more or less 100 meters up to 2050, 500 in this domain. So now, once you have your big resolution, you have your bathymetry, then you can define your mesh mask. So for the point and end point. And this is our situation. This one is our mesh mask, and you can see here, blue are the C point. We have just one C point here, this area, and also in the day you have a few points, and we see that it's not well represented dynamic, but there are something going on there. Then, yeah, we are using Cements global data as input downscaling. Yeah, this is just the global product. I just add the GIF for, I don't know.
Which day?
No, actually, this is represent the current in 1 year of the analysis 2022. I have the batch. And no, just to see the patterns here. And here we have the Brazilian current. It is part of the west boundary current in South Atlantic tropical gyre. Just find some representation of circulation here. We are in this area. There is this Brazilian current we see in simulation. It flow southward along the continental shelf, transporting more water, and then we have this the other direction, the Malvinas current, flowing the other direction, that carrying cold water, and here the outside our model. I just to show the patterns in this area that there is this sort of convergence where the two current interact and generate energetic negative. What we was see in this area. So from the global Cements model. Okay. Now configuration. So
We need to go to it.
we need to go to it.
Fine.
But this is the configuration that we find in our JSON. So this one is the configuration. Okay, we jump. We fix some all the numerical scheme and parameterization. So there is a default that we define for the basic application that we are confident with. And these are the results. So this is parent, child, current.
Don't go so fast of the parent. Parent, the circulation is Siemens.
Yeah.
And the child is the one with the three times the number of dots, right?
And we can see the flows on it came from north. We can see that boundary is more or less the direction of the parent current. In this area, we have jet that is interacting with this vortex. That is transporting warm water from north on the net, and this vortex is moving, connected with the slope.
How long does it take the simulation?
The simulation will take 1 hour. The process is plus simulation. So when we come after we download the data, in 1 hour we will complete with you will see the results. Okay, so these are the concept related to first schema. Okay.
I have two questions. Can we arbitrarily determine the grid spacing of the downscaler?
What do you mean arbitrary?
For example, if you set it for 10 kilometers, I can set it for 10 meters.
Okay, so yeah. Normally our approach when we do downscaling is to be in a grid ratio, so parent child, from 2, 3, sometimes 4. So there are many paper that recommend to not do a big jump between grid resolution of parent and child. So if you want to reach, for example, I want to reach 500 meters, I start with the Cements, okay, and then I do, okay, perhaps reach 5 meters I need to do 2 downscaling. I start with a bigger domain with of course like 3 kilometers or 2 kilometers.
That one.
That one, okay, you can use also region 4, like 2 kilometers, and then another region 4, you can go from 2 kilometers to 500 meters. So you do down multiple nesting on that scale.
Which is, by the way, this is one of the features of SUR.
Yeah, one of the features. Also, now in the version,
Don't worry about that.
yeah, however, there is
Okay,
the
it
future.
is a feature of SUR.
That automatically you do, I want to do to downscaling, I want to reach 500 meters, and automatically it will do first, finish, and use the output as input of the second.
So you cannot do it in one jump.
Right.
That is for sure. You have to do 2 jumps. Or who answers?
Sure. Yeah.
Or use a surf Schleifen,
Oh, yeah.
which,
Does that, again, I'm sorry.
okay, so, or use a surf Schleifen, the unstructured grid.
One question then. I noticed that your JEPCO bathymetric data set was from 2014. Would you be able to input a newer version or you stuck?
Now the new version is one old version. And the version we have 2024 newest one. So because the update one from the old one double resolution. So what we done was 13 up second, now they are 15 up second, very high resolution.
Yes.
And also they continue to update every year to better
Very good product.
better resolve the bathymetry in many areas.
Thank you.
If you don't have credit from Siemens, can you still run the model? Like, for example, if you want to simulate the area that not available in Siemens, can you still simulate?
Okay, so but you have it means I have another product from another operational system.
There isn't. It doesn't.
No, if you don't have, you can. Because without scaling, you start with initial condition and boundary condition that are taken from outside, from another model, another system. And now we have operational system that give us is every day updating and checking. If you don't have it, but if you have another system,
And how's about the other operational, like Moody's?
All this is not operational, it's only a satellite data set, surface. It's not giving the deep ocean, it's not giving all the variable, more this is optics, right? Different,
you need as input the
very different.
temperature, the temperature, salinity, SSH, and the cartridges. So these 5 variables need to be present in your system for fast simulation that now are automatically taken from Siemens.
Yeah, in the world, Siemens is the only one in the world that gives you this first guess. It's the famous concept of the first guess. You start from that and you improve. You cannot start from scratch. So you start from this and you improve. That's a lot of engineering is done in this way, and it's good to do it this way. So look, for example, this nice picture that's, Francisco, it's fantastic. Because, look, see, Siemens sees not this coast, it sees another edge. Siemens goes on land. Siemens does not cover the ocean in the bay. See, it arrives up to here. Because here you see exactly what Siemens big boxes see. So the representation, you see also, this is very good plotting. Nice.
Yeah, there are 2 options also.
This is a nice, it's difficult to see this normally because people hide it. Now here, you see?
Yeah, there are, okay, you can do plotting with a contour or with or only like a shape, like in Python is called a PP shape. Because in this way, you will assign a pixel the right value. In the other way, there is no rendering color, interpolation color, so there is no.
You don't see.
It's the honest way.
Right?
This is the honest way to go on.
That's the honest.
The honest also, sometimes but the one contour sometimes more elegant.
No.
For paper.
Not for scientists.
But to check, if you want to check and see and control if you have some problem, is the best way to plot your.
So what do you see from these two pictures? For example, the same scheme for plotting has been used on the second one. It's exactly the same, but now we have 3 times more grid points. And all of a sudden, it seems smooth. But the plotting is the same. So we see the high resolution makes the features already better. You don't need to do smoothing. Right? So this is the incredible advantage. Not advantage, I say, the only way to go, because I mean, smoothing is, it's not a process in the ocean, smoothing is within that, it's something smooth in the ocean, no, there is some. So that's not.
Okay.
You see also here, what is the column?
So also here there is density, the velocity field, and there is the vector field on top. And you can see also the 9 kilometer box and the 3 kilometer box here that we represent the intensity of the velocity.
So we give you a plotting that shows you the reality. Now, if you want to massage the reality because you have a policy maker that doesn't want to, no, policy maker doesn't want to know the boxes, right? I mean, they don't want to, so you can smooth it. Massage and so, and it doesn't matter for them. So now, but you have to see it. You have to see what is your model doing. Yeah.
Oh, for this astron, actually, I prepared two areas. So by default is one, but this will take 7 GB of RAM. If you don't have 7 GB, there is another one that I got more or less here. It is 3.7 GB. So
now we don't even have the machine, so let's see if we can get something.
okay, so it's good. Yeah, super. So yeah, so this is what I want to say. I don't know if we have time for shy now before lunch.
No, I don't think so. Yeah, shy. Yeah, that's right. But we were thinking we should go to lunch.
Yeah. It's almost 1:30.
Yeah, so we should go, right?
I don't know.
That's why we take a break. So you will get that this is the box. Everything is ready to work. It takes only time to get acquainted with this JSON and few things, and then the rest has been given to you working. Okay, so okay.
Yeah. So in the afternoon, Rodrigo can do this. Before to start, better that we show the JSON more or less action just to be.
Before we have them ready.
No, after they are ready to go. Just to show the section they need to change if they want to change. A good idea to present the JSON. That you need just to touch the JSON. The other stuff, everything is automatic.
Yeah,
So just to be confident.
I will wait. I will do first the exercise. So the thing that you have downloaded.
During this,
will produce these fields.
yeah. During the exercise, we have 1 hour. In that 1 hour, that we need to wait. We can check the JSON.
Just to confirm, very quickly. I see this is surface currents, yes, but you can get currents 3D.
Oh, sure.
Yeah.
Yeah.
Ocean temperatures too, of course.
Temperature, salinity.
No, yeah. In the post-processing, that is still work in progress, there is not the transact. You have to do yourself.
You can take the data and see, do the translate yourself.
You can do yourself if you want, but you have the data, so.
Yeah, no, I just need the data, so.
Pretty much nothing.
You know that Francesco is a perfectionist, so he has already the sections, but he wants to make it perfect. And, yeah. Okay, so that's, it's true, it's true. So, yeah, so this is, you know, you will get to the three-dimensional. You can decide which parents to plot from JSON.
You can decide which level 0, level 2, level 3, and so on.
That is a good exercise this afternoon.
And also, actually, if you want, I also prepare some notebook for validation. I didn't check. You compare the temperature with satellite. I think it's a good exercise to do if you want. After, I don't know, let's see how much it takes to do this exercise. Yeah.
Choose which type of downscaling we want to use or anything else.
What do you mean, which type?
Now, for sure, there are many downscaling methods, or can we choose it?
And now,
What are the many downscaling methods?
I'm not an expert in that.
Oh, okay, but you have an impression that there are many.
The statistical.
yeah, this one is done for that scaling one-way nesting. So they use information from the course resolution to ambiguity.
It works like the parent model works. That's the idea.
Yeah, with the high resolution. So it just
Yeah.
we fit the adjustment file.
Which you will use. The nesting always works. Like there's no failure.
No.
Okay. It is. Before I was using Dell, and this is a manual nesting. So sometimes the data from the when you check from the parent and the private model, when you check the values at the boundaries, sometimes they don't match.
Yeah. The boundaries are the problem.
Yeah.
Yeah.
So
Yeah, totally
this one is success. There's no failure.
Oh.
Oh, okay,
You know what
okay.
we do? Don't have a story.
We implement now, we are upgrading the core model, and normally we do this every 2 years. Now we just upgraded to the old version, Nemo to the new version. They have many other scheme parameterization that now we also use this configuration as default. We are in the phase that we are checking, validate, compare, and perhaps there will be some domain that will have some stability. And also in the manual, we are trying also to put a section what to do if we have this problem. We need to smooth the bathymetry. You need to just a little bit move your open boundary, because there are some situations where your configuration creates this kind of numeric stability that your model will blow up after a few days, for example. So it can happen that your model will blow up. Now I give you some that is working, but normally, yeah, it's stable in many different areas. But yeah, we are. I put alpha version because we are in checking, so we are.
No, but there is no solution actually to this problem. Okay, fundamentally, there is no theorem of existence and uniqueness of an open domain Navier-Stokes equations. This is the famous field method for mathematics that hasn't been taken by anybody. Huh?
The Millennium Prize?
Yeah, the Millennium Prize. So this is the problem. And we use the practical approach, which means that you change your boundaries, right? In fact, Francesco had to change the boundaries. It doesn't say, but he's an expert, so he can choose almost immediately the best boundaries. But the rule is, I can tell you the rule. The rule is put your lateral boundary as far as possible for your computational resources and everything from where you are interested in the downscaling. that is the safe way to work. You can try to change the boundary conditions, but that doesn't save you 90% of the times. The 10% of the times, you are still bound by this fundamental instability of the solution that you cannot determine properly. So there is a question in the space.
Online. So Bernard Asseni has asked 3 questions. The first one, are the river runoffs part of the lateral OB section?
No, I don't know. We, in this new version 2.1, we have the possibility to use river runoff, but not at river boundary where there are the rivers. So there is also documentation how to do. You just have to add the river file, then tell you the river runoff.
Yes, it is.
So
The answer is yes.
Yes, it's a
Oh, okay. Second one, what would be the better scale factor between parent and child breeds?
And what I just said, so the ratio we are normally by 3.
3.
3 as a ratio.
3 is the ratio.
And obviously, what the user need to do when in downscaling and is to define the time step, baroclean time step. It's the only thing that at least about this default configuration you need to adapt according to your parent model. So if you downscaling from I don't know, the global channels, they normally use 400 seconds as a baroclean time step. You need to put a right time step that allows you to your solution to be stable, so that satisfy the stability conditions. And so we will use this experiment 120 seconds.
Yeah, but this is a consequence of your choice of the.
But this is an input of the user to put the right time step. So sometimes it blow up because you have a bigger time step. So you user need to be aware that you need to control that variable.
And the last one, can we nest regular parent breed with an irregular child breed or reverse?
Can we nest a regular parent? Yes. So we.
This is the other thing that name of that you surf that. Say it.
Okay, now in this version we can use the grid of Ciments grid, so a regular grid. Like a global, the main product, all the products of Ciments are compatible with this software. And by default, we define as a child a regular lateral grid.
But I finish. But the global grid might not be regular. It might be still an orthogonal grid, but not regular.
Yeah.
Okay, so it means that near the poles, we did downscaling in fjords, near the poles, the grid is all deformed. It is still rectangular, meaning that the velocities are perpendicular to these sloping boundaries of the grid. And so you need a particular transformation. Surf is one of the few ones that has that transformation.
It was in the old version, the new version, we just removed, but we will add again. Because now,
Remove them by.
in the last 1 year, there was a transformation of code because we are changing generations of the code and something that we are still missing from the old version. But this one is important because in some cases you want to start from the actually output of the global model that is not running in a structured, in a regular lateral grid. It's running on a tripolar grid. So if you want to do directly without adding the normal interpolation that Maps does, you want to do yourself or you want to do to the package. The package also can deal with a tripolar grid as an input from the global model, like it's a stretched grid that is used from global.
So let me tell you where the boundary should not go in this flow field. This one, this is the global. The boundary should not go here. because the flow is parallel to the coast. And what does it mean? Flow is parallel to the boundary, so you don't know if it is an inflow or outflow, because all the boundary conditions are determined on the basis that it is an outflow or it is an inflow. So here it becomes, if you put the boundary here, you'll get a problem. No, you get a problem because it's underdetermined. Is it an outflow or it's parallel? So it's neither an outflow nor an inflow. So you never put your boundary parallel to the flow field, always across. So it's very simple physical mechanism, not difficult, right? Because when you have an inflow, you have to bring the quantity in, and then you find the boundary condition, how to do that. When the flow is outflow, you have to tell, go out. And you can do that. You can write things that tell this to the code. But when it's parallel, the code doesn't know what to do. You never want to put your model in the condition of not knowing what to do, because it means it will be unstable, it will give you an unphysical solution. So first thing is to find, maybe you have also, with your experience, some other decisions.
No, yeah. This, and normally also what I normally do also, but this is when you define the grid of the child model, sometimes to avoid also, I use also to overlap the child grid or
That's very important.
parent grid. For example, if you can see, but the system works also without.
Yeah, but it's good to say that
You
have to be careful.
if you see, I think from here, this is just child, but if you go to the parent child, for example here, okay, you see the child are overlapped to the parent when they are overlapped. But you can also do this defining the corner of your child model and not be overlapping. In this way, when you do our linear interpolation, at this point there is not interpolation.
Go to the previous one. Go to the previous, the one you were zooming.
This one.
No, it was a previous one.
Yeah, this one.
So bathymetry is the other constraint. You never want to have your child bathymetry to be different too much at the boundaries from the parent, because then you don't know the net transport. When you have a Gauss stream, a Brazilian current or a Gauss stream, the net transport is tens of Sverdrup, and that is water. There's no way you can. Yeah. So yes. So you see, and you had one now without bathymetry, right? You don't have the bathymetry here.
No,
No.
yes.
Okay, so here, for example, in this boundary, you should have the parent bathymetry in this grid point, and in the one in the middle with the smoothing to be the same between the parent and the child model.
And now
You don't want to get that problem.
then in the pre-processing normally what we normally use also, but use to smooth the bathymetry. Sometimes there is some area when this general solution bathymetry.
So where did you smooth your bathymetry here? In how many points?
No, we are smoothing all of the domain. We are not smoothing the bathymetry just on the boundary.
Okay.
So we are moving. And if
Even in the Brazilian
if you
case?
check the tonality phase, but for now you need to do manual if you want to check the bathymetry parent child boundary.
I wouldn't recommend.
But for now, to avoid that there is some spike, some very one point mountain in some way, using that can be a problem for the numerics. You can smooth a little bit your bathymetry.
But how do you smooth it?
We are
Which is the algorithm?
we are using
The best.
The Shapiro filter.
The Shapiro filter, the best.
Shapiro
Which
filter,
order?
where we are using second order with the 4 application by default. But you as user, if you want more, you apply more time with Shapiro. There are two
Shapiro
parameters.
is a good filter, has been shown a long time ago to be a filter that maintains the structure, takes out only the small wiggles, because, of the symmetry. So that's another good art to observe of what we have built in from experience long time ago. And it normally is a very delicate, if you don't use the Shapiro filter, you have to be very careful to smooth the bathymetry. You're going to get unphysical solutions. Bathymetry is very important for the ocean. So now, this is given as a pre-processing
It's a pre-processing.
in the code. So you can use it, become master. People become masters of this, right? So that's why we need artificial intelligence, because brain has a certain dimension and then we can become master of everything. Yeah. Very good. Yeah.
What is physical solution?
Hmm.
What it is?
What it is.
Yes.
Yeah. And on physical solution, do you have the old run of this model with physical solutions?
It means unphysical that
That you judge that there is a problem in your setting. That's what you're asking, right?
Yes, because you just mentioned it. It's like
okay. There are many possibilities that your solution can be
So but
physical.
how do you judge it?
And normally you can judge validating your model, comparing with the in-situ observation, satellite observation. You check your root square. You
Yeah,
check
let's do
your
the
life.
one that we do all the time.
You can do satellite observation.
It's visual.
Visual.
You get experience, you start to see that there is a wiggle. Why don't you show your currents? I show the wiggle, the hidden wiggle.
Yeah,
there is a problem there.
there is something that
No, don't worry, we show it, we show it.
and because we change
But it resists.
in
The
Nemo 5.
wiggle does not amplify. So that's another point. What we did a long time ago is that we know we don't have a solution that is theoretically possible, but we have a practical solution. And the perturbation don't grow for 10 days or just enough to deteriorate your solution. Unphysical means deterioration. So a solution has no you've never seen in that region. When the currents are, too wiggly or have a strange temperature, maybe negative, so it's unphysical. Where is it?
Yeah,
Show
this
the
is why also we released
Show
the
the problem.
alpha version, because I'm still dealing with all this problem. If you can see, these are the daily mean of the first day, and we got some oscillation at the boundary.
No, I don't know if people see it, because you see it, I see it. You see these oscillations here? Come close. You see it? It is, show it, it's important, it's not, this model was set up
Oh, this is
in half a day by Francesco, right? So you would expect it not to be perfect. Come close. See, there. Now
Okay, now I see.
Now, we know this is unphysical.
Is a
We
problem.
know, I can assure you this is unphysical. There's nothing here that brings the surface velocity, this is the daily mean, temperature, sorry, it is the temperature, that makes the temperature of being hot all around the boundary this way. The temperature should be like this. That's the parent, but the parent gives some information here in that translated into the boundary condition.
So yeah, I was checking the data or inputs and the
This is
algorithm,
perfect.
the algorithm of the boundary, and yeah, I will try to resolve as soon as possible for the factories.
And you have the option, a set of boundary conditions like the flatter, Chapman,
Yeah, for example, now,
merging.
yeah, for now, for our default is the flux relaxation scheme for the temperature, salinity, and the barotropic velocity. And then for the barotropic we also flooded, but we want to give several options. And yeah, so
Flavor is impossible to change. So flavor you have to do. You have a topic because of the fast one makes the table immediately. But for temperature and salinity and velocity, we're not, we're not using the best.
we're using the same as the old version, Nemo 3.6, but in some way now it's so perhaps it's connected to activity, or perhaps I don't know, it's connected with the.
We will find out.
We will find out and.
Nice.
It's another science.
This is a fantastic example. So you see the good, but you see also the good thing. That's what I was saying. That this part does not affect here. If we are interested here, because also this is a system that gets renewed every day. Every day you restart from Cmax. You will not be able to run this continuous. Also, that's another thing that you learn. You have to restart the system, refresh the system. But this is exactly what I was saying. This noise is not affecting here. So I'm okay. I'm okay. And every 8 days, it doesn't explode, it doesn't grow, because before, when we had a different boundary, it was bigger.
Yeah, there are many problems where after, I don't know, 1 hour your model will explode, especially, for example, when you need to apply the Shapiro because there is some bitter point, mountain, very one point, it gives you see the problem and will explode after 10 times that. It will explode after you have, for example, you put the wrong step. Does not satisfy the condition, just the condition we see after 1 hour it explode. So there are many problems that you can due to numerically or due also with some value for parameterization. We have now defined the factorization also of viscosity, fluidity, starting from the value of the parent. For example, this is the way to have at least a good starting point for the viscosity diffusivity. But if you want to actually increase your skill, perhaps for that region you need to change the parameter. Because every area in the world are peculiar. Depends on
We need to go.
Let's go.
Thank you.
Thank you.
Very good, very good.
I also. Yes, it is, Yes, it is. Actually.
You guys, let's go to lunch. I could have social, and I could have the soup. Here to share it.
Here to share the screen.
I will put the phone.
Ok.
Você fala.
Sim.
Foi a tela inteira, porque se você colocar uma apresentação, aí ela sai, sabe? Da
Sim,
tela.
sim, sim. Okay, all right. So let's explain this first then. What is each file? So basically, in the process until now, you started downloading this file here, which is just the software of the VirtualBox, right? So this gives the base so that you can import an emulator of an environment of another file system to work in yours. We need a bash session to run our code, our model. So we are downloading an emulator of Linux and putting it inside our Windows so that we can run. So this part here, it's just, let's say, logistics. Okay, we download this, we install VirtualBox, and inside the VirtualBox, we are importing a virtual machine, a Linux environment. Okay, so this part here, it's just, let's say, the wheels of our car. We are interested in the car itself, but we have to make that car run, right? So we are installing the VirtualBox and importing an emulator of a Linux environment. That's all. So now you have Linux inside your Windows. But so you have to download the virtual machine, Docker, and the file officer. Yes, Natalia. Yes. I can also share the links in the chat right after. All the links for the softwares, for the virtual machine, and for the Docker image. Now, the main thing, the main file among all of them is this one, Surfshife here. For some of you, Surf Nemo, depending on the model you chose. This is the one you are interested in. It's the heavy one of 7.5 gigabytes. This is the one you want to run inside the virtual machine. Okay, so all this talk of the virtual machine and the emulator of the virtual machine, the Surf virtual machine, it's just to make run our model. Okay, which is the exercise of this afternoon. Is it clear now? Yes, okay? Okay, good. So I will open VirtualBox here where we imported the emulator of our virtual machine, our Linux environment. I will start.
Did you choose the basic mode or the expert mode?
Of Oracle VirtualBox?
Yeah.
I didn't follow the installation.
Okay.
When you installed, what did you choose?
It's just.
I think it was the automatic steps.
Yeah. Okay.
Yeah. Okay. So we are going to change some settings of the virtual machine. Okay, you click on settings here. Let me show again. Settings. Okay. And then here on system, we'll just make sure that we give the virtual machine enough memory, not too much, because otherwise you can block your guest system. Okay, so your Windows can get blocked because you gave too much resources to the Linux. Put it in a half or even a bit less, like this. The processors, the simulations we are going to run in parallel mode. And we are going to give 4 CPUs to the model. So give at least 4 here. These are actually, I think this here it says CPUs, but I'm pretty sure that these are cores. In this case here, we should have at least 2 CPUs in each core. So I'm actually giving 8. Okay. And then on the storage, this is the part we are going to do some stuff. Did this work for you in the end? Yeah. Yes. So you loaded the image. How good? Or is it loaded?
It's loaded. Am I supposed to wait for this to finish to do this?
No. So far, so good.
Okay.
And also, we have a problem. There is. You have a problem.
I can open this window configuration. I can.
You can adjust the
The,
MD up.
yes, I can move anything.
Sorry, I forgot to mention that to change the settings, your virtual machine has to be off. So if it's open, you have to close it first. Also, let me remember, somewhere here there is a way of creating a sharing between your guest and your host system for copy and paste. So to copy and paste commands when you're following installation can be useful. You remember what it is? Yeah, I think it's this one here. Yeah. So on the second tab here on general settings, there is a tab called features. You can choose to create a sharing. Here is in Portuguese, but it should be sharing something.
Features.
From the host to the guest, this would be our option.
Hospedadeira. Convidado.
On the storage here, let's go back. This is the partition we are creating on our host hard disk to give to the virtual machine, okay? So we preset for 40 gigabytes. I mean, our model needs much less than that, okay? They're not going to consume 50 gigabytes of your computer just to run one simulation. But we created this virtual size, but somehow when we import it in the virtual machine, the actual size is much less. It's 25%. See, so there is only 10 gigabytes of this 40 available. So we're just going to run 2 commands inside the virtual machine just to make it understand that it can actually use the entire thing. So here I'm going a bit slow here because we're waiting for a test. But it works like this. You're going to an image, but it should. We are going to check together. We're not afraid. Okay. Last thing that we need to do before launching the virtual machine is to create a sharing, a folder to share. This will be the point of connection between your host and your guest. So if you want to transfer files from your Linux to your Windows or from your Windows to your Linux, this file needs to be inside this directory or be transferred to this directory. Okay, so when you want to take if you want to take the results of our simulation out of the virtual machine to actually be post-processed in our Windows, we need to copy them to this directory. Okay, but you need to choose which folder to share. So you click on the plus here on the right.
Rodrigo, can I do this later? Because it's like running the code, the loading.
Yeah.
This part.
This part, yes, yes, yeah. Actually, better that you load the image. This way we know it works. These procedures here you can do whenever you want.
Okay.
You can do whenever you want. So I'll create something symbolic here. I will share the.
It has to be in the same disk. If it's in C,
Okay, yes, it has to be in the.
it has to be in the C.
Yes. I create it. I called mine Surfshark. I'm sure you can call it whatever you want. I created a directory and I'm sharing it. Okay. This is the name I actually want to see on my virtual machine. And I'm going to mount it automatically This means it's like you're plugging it to your Linux computer. You're adding an SSD, okay, in which you can share and you can copy and paste files, and I'll make it global. Good. Okay, so we finished the setting of the virtual machine. Okay.
Oh, wait. I see from the back.
Okay. Yes. Set. And I'm going to launch the virtual machine. Okay.
Yes.
Didn't finish loading. It should take 5 minutes.
Wait. You're not doing it?
Okay.
You're not doing it?
Oh, they are done.
You're already
She
doing
doesn't have space.
it. Is that for you?
Yeah, because
Are you working with her?
it's still running with Linux. I stopped it and then when I stopped it, it's still gonna let me modify anything.
Are we working?
All good.
Deixa a imagem.
Can you see this one? Yes.
But even though when I stopped it,
Just created it.
Now you have to finish the process.
Only tem uma imagem marcante disso.
but it's not moving.
Mistakes are coming.
And I'm here. Where are you?
It's been like this like for 5 minutes.
It happens to me. It happens to me six and then it's forward.
But the comparison is only. Alright, cute. But like it is running, right?
Now it's no.
I'm not sure
Yeah, there is a command on the documentation.
No documentation, we can do documentation.
Now they just do.
Do it now, do it now.
Okay, same command. Okay, look at what minus I. Okay, let's repeat the sentence. We already have the machine. We're just going through the settings. It wasn't working because you had the machine running. The engine was running. So now you can change parameters and stuff. Seconds. Right? Motherboard. I would reduce. Okay, just that's it.
Storage.
I mean, to run the code or to do what you
Sure.
depends on.
It is, because we are saying distribution box.
I'm sorry.
Distribution box is used for it, and you say, are you sure? The sharing is. That's okay. Let's- And let's now.
I don't know if still working on. Is it running? Yeah.
You know, Rodrigo. Ela obedeceu. Okay, now we are inside the virtual machine. We are going to open. Not really.
Why don't you look there?
It is still running.
It was running perfectly fine, but then when you started doing stuff, I stopped it from running here. Like I held it, saved it, and then usually I clearly now it's not like the base is
Where are you going? See? Here.
So it's, now we have so many processes.
Okay, you don't need to download this. You can extend that.
Memory.
We're going to use this.
How about here?
So the virtual machine for this you need the setting. You did changes now.
because when I tried to do it, it wasn't letting me modify anything.
I saw the mouse moving and I'm not there. So it's a remote access. I think I have some time before you understand what you're doing. Features, first you're going to allow a sharing of clipboards. You'll be able to. Yeah. Run memories to use 32 bits. So we don't need that amount. How do you do this? So it says the simulation are going to run. Basically, here's your run about a day. We're going to break the main 4 pieces and give 1 piece to each processor. Your computer is a big calculator. So you're saying new calculator 1, compute the solution here, so you need to give a piece 4. And then we're not storage. This is the thing we are changing now. Basically, this was the public, not yet. We created the virtual machine and said you can use 40 gigabytes. The virtual machine said, are you sure? So you allocated 40, but it's using only 10. So we are solving that.
But as everybody
No,
else.
no, just ignore this presentation.
Yeah, we are solving all together now. Not everyone. Here we are going to create a point of contact between your host and your guest machine. Okay? Create a directory. Sure. You already created a directory for the information for this piece of this. Create one.
I can just create it.
Yes. Call it whatever you want, just avoid spaces. Select folder. We are going to auto mount. This is important. We're going to make it global. Then here done. Okay. And we launch the machine.
I need to get the.
How do you launch a machine? Are you still
Start.
there?
Start. Yeah. Then now we enter the.
Exactly, where you were before, so let's wait until she does.
In Windows, not yet.
Yes, it is possible.
It is.
Master and university. It's, no, it's because what we did before is that all it was already inside a virtual machine, so we could download the
Okay,
virtual
that's
machine
good.
without.
That's where I am.
Okay, but
But it was very loud.
No, not yet. We'll get together.
all right.
Okay, all good for everyone. We are here. Everyone. Okay. Right. So you're going to open a bash session or a terminal. Click on the terminal. So Windows users, are you familiar with the bash session, some command lines like change directory, CD? Yes. Yes. Okay.
Yes or no?
Yes.
Okay.
Okay, I know what they are, but I'm not familiar with them.
Okay. Yeah, but if you understand what you're doing, it's with practice. Okay.
So I mean, everybody is in that window, are you sure?
Who is not in this window?
I have this here.
Okay, the password of the virtual machine is served. We have this in our documentation, okay? In the website, we have this step-by-step what I'm doing.
Yeah, but they have to do it now. They have to say,
Absolutely.
sir, is
The password.
the password.
So if your virtual machine gets blocked, the password is password. The name that you see in the screen, sir, is the password.
Sorry, but other people here, do you have that in your screen? Are you exactly here? Are you exactly here? There? Are you?
That's it. I'm on the password screen.
Surf. The password is surf. Got
Okay, we want everybody to be on that screen.
In space. Yes, it is in everything must be very space, right? Yes.
Is it basically intent?
Yes.
No, no, no. They just
Okay, no, it shouldn't depend on usage is less the already downloaded more than 9 gigabytes of data since I know it is corrupting all my computer. But I have no uninstall. Yeah, uninstall. Quick. Uninstall Windows. The organization selected your or let me just claim on this one. I don't if nobody's meaning is about because I click on examine this usage and then to be like this. So like this is the load layer, the loading layer. It is size. Yes. Your CV is like zero. You need to start losing. No, I mean, you're buying. Okay. No, stay here. Fechei ela só. Second topic que ela passou. Fiquei pensando isso. Parece mesmo que é e aí, será que eu entro? Sim. Eu tô na mesma situação, eu tenho medo de fechar e de. Eu vou fechar aqui. Eu vou fechar, vai chamar. I tried it and what happened? I don't know. It just works. So you do a very good food and just all this happy out to do it.
When very big fast, yes, after some of the normal what is very like
So how are we? How are we?
Okay, so
Yes.
I'm there.
who is ready to run the Nemo? We have to already the image imported on the Docker server, the desktop, the Docker demo.
Raise your hand if you.
Who will run Nemo? Well, we need Nemo. Okay, super. No other business.
Yeah, I think so. The image is the.
If you check, go to terminal, and we will check if you have so.
So Francesco, why don't you stay at in the terminal? Yeah, so that people can see.
Yeah, actually, I can go at the terminal, share the screen.
Not share your screen, why? Please.
I think very good.
But the majority, Francesco, is showing the Scheißen, right?
Yeah, 60%, 40% left. Yeah, majority shine. But Nemo, shine. Nemo.
No. Emo.
That's how we connect. Okay. Rodrigo, can I connect to my computer? No, with your computer, no.
That is the computer actually. Okay. Using the link, you can also direct it.
No, so.
Higher generation. Mine is I think this is a newer.
So you go in another room, maybe? Yeah, so.
The Linux, I want to run on the Linux.
So it doesn't matter Linux server. Who does Nemo goes with Francesco. Do we have another place to stay?
Yeah, how many people?
Nemo.
Can you take your hand up, please?
For Nemo. Okay.
And for Nemo, okay. Plus 1, 5, Francesco.
Leva o Francesco, por favor, junto com outras 4 pessoas lá para minha sala.
Funciona.
Aí liga lá a máquina para ele lá.
Tá bom.
Ah, thank you. You take with your computer.
With your computer and the charger. The charger.
Yeah, I don't know if you have plugs for every charger.
You are charged.
They're charging.
This
Battery.
It doesn't matter. I'll do both anyway. This machine is too slow.
No, but it's a problem if you cannot charge there.
Hey, good.
I'll go eat back for my clothes. Are you going to take any of that? I think so. I have Nemo.
Right.
Yes. And I'll take this with me. But I'll come back for the, my thing is charging. I'll come back. Right? I'll say it in a minute. Wi-Fi. Pegar seu que achar aqui, ó. Tá aqui. Tem que não. É isso daqui, né? Qual que tá ali? A gente vai usar esse daqui mesmo. Sim. Então copia daqui e pega direto pra ver.
Não, pior é que externamente, o cara da TI tinha que estar lá. O nosso? É, a gente vai estar lá. Entendeu? Vale a pena dar um.
Lá a gente B maiúsculo, equals,
What does it mean, Peter? Is it good or is it bad? Okay, he said, okay, it's how good or is it bad? It was a dismayed, okay, right?
Totally. So what if I just went off? If then I was
Interesting, because mine is on, so I don't know.
yeah, I just went from.
do isso?
No, the same users. Come with just Windows você respira.
É. Aí, assume aí do. Gabriel. Box.
Pode ser. Box.
Espaço. Ah, então foi isso aí, tá? Você pegou outro.
Escondido. Não.
Não, é bem é isso aí que tá de pé, tá de pé. Aí, foi isso aí. Sir, B. Aí, veterano.
I'm breaking.
Sai.
No.
Interessante também.
Okay. And
Looking wish me you did.
so I missed one step before. You have to take one step back to give then forward after, okay? So open the virtual machine and now close it. Yes. So you open it and then here on top you have shut down. Yes. Can I have the command? Can you? So, unfortunately, it's not very clean. It should increase the size of the hard disk with VirtualBox. We need to do it from command line in Windows. So basically, you choose Windows not to use command line. That's the principle. You want a graphical interface, you want everything nice, easy. But here there isn't a way. I took 5 minutes to make a research to see if there is a way of going click, increase and stuff, but there isn't. So I have to do it from the prompt of command, okay? So you click here on the start typing prompt and you will see the application.
Remember that everyone that it's outside the virtual box.
Okay. Yes, you have to switch off the VirtualBox before. What? Are we good? Okay. So now we are going to type a command here, saying to VirtualBox, speaking directly to the executable of VirtualBox to increase the size for that specific partition of a specific virtual machine, okay? So do it with me. I'm also getting used to the keyboard. So remember the directions of Olivia yesterday. Be nice, be nice, be nice. C, and then you are going to access. If you installed VirtualBox in your disk C, you are going to put C. If it's in the D, E, F, you put the one that corresponds, okay? As you type this command, you can press tab. If the thing completes automatically, it means that you're in the good way. If it doesn't complete automatically, it means that you missed something, okay? So if you put the backslash here, start typing program files. Every time it's going to add this this thing again, you just erase it so that we can keep typing our path. Let's go on. We are going to the folder where our VirtualBox is installed, okay? So Oracle, virtual, start typing virtual, press tab, it completes automatically. Did we miss anyone? So far, so good? Yes? Yeah?
We're looking for the work.
The backslash.
Yeah.
Yes.
I can't find it.
Yes. We can try to ask.
What is backslash? Did you find the backslash?
Okay, VirtualBox backslash this one. Okay. Then here it's not going to be it's going to be manage.
Right.
I think you have to change your
Yeah.
yeah.
English.
Yeah.
You made it? Have you made it?
Thank you.
Yeah, has there.
Programs.
So here basically we reach the executable of VirtualBox and we are going to say modify hard disk.
Oh, I have to write it.
Yes.
Okay.
Then we are going to give now the path to the
It's done. Yeah.
hard disk of our virtual machine, okay?
It's much
Can you see this? Users, here it will be this here will be administrator. Like, oops.
You copy this?
Get bigger.
No.
Let me see if I can make this. Yeah, you mean the font, right?
And
I don't think there is a way. Sorry.
It's to make it bigger.
Users default. Do you know, sabe, Carla, qual o usuário que é aqui?
Every time I change, for everything was clear.
I should just go on.
Of the users. He used the main, great. He is what? He used the admin. Default user, but I tried that one.
Eu vou perguntar qual foi o usuário que eu vou
So here, yeah, we are trying to where we are, but in your case, it will be the name of your user of your computer, okay? Oh, please. Eu acho que não. Eu acho que não. Eu só precisava de um caminho. Qual disco a gente instalou, qual usuário a gente estava ligando. Nossa, reunião. Eu consigo ver aqui, né? Features. Você, usuários. Usuários.
Você quer ver esse parlamento? Dos dois.
Acho que aqui tem um jeito.
Eu vou caminho. Botão direito.
Sim, é isso que eu queria ver.
A gente está nos mais ou
Tem como copiar aqui o caminho?
Agora eu fiz com as logs.
Ah, wait, there is another way. É esse daqui, o caminho dele. Administrador. Okay, you can copy it here also, guys. Open the settings window of your virtual machine, the same one that we used to change the number of CPUs and the size. And you can copy it here. Okay. Okay. Yours is good. And you're going to paste it too.
Mohammed is trying to run as well. It's running as well.
Okay.
The same as me.
Nice. Okay. And then after, when you relaunch the virtual machine, there are two commands that have to be inside. Okay. Are we good, everyone? Storage.
Wait. Has to get. Because there's two commands there. That's. It's just what it has to do. Because right to see.
Yeah, you don't run it yet. It's missing one thing. You have to say increase by which amount. Yes, you thought it was that simple. So you're going to do minus minus resize, and let's give it at least, just to be sure. Of course, we're not going to use that, but let's try to give it at least 70 gigabytes. Okay. The size you need to give it, no, don't need it. Relax, we don't need it. No, we don't need it. It's just for us not to risk having to do the procedure again. You know, we don't need it. I repeat, we don't need it. We have to give the size in megabytes, so 70,000.
Take notes. I said, make sure I take notes.
Okay. Good. So run it. And it doesn't run. Permission problem. Okay. I think in my case I have I need administrator rights, but in yours it should be okay.
What is that?
There is something
It's probably modified. Never.
just
Evox manage. EX. Modified. Before that, before that.
It's this one.
Yeah, right.
That's the one.
Yeah, it's doing.
Hey.
35 HG. Exactly. Right.
In space here.
I hate this.
Yeah.
I need to copy the.
You do it.
I can't, I have to
go back like this.
This, yeah. Do they have,
I know that. I should have known it before.
how you go all the way.
It's okay, it's better than the video.
Include this.
So it works.
Or I need to find it.
Sure.
Valid.
Quer dizer,
It's like
wrong?
zero charge.
Eles estão tem
Something here. Probably.
It's wrong in the second.
Yeah, probably something.
But I copy from somewhere. So I copy from here.
Oh.
Let me see the error.
Zero.
Valid. Six.
With 1 0.
Unexpected one.
Yeah, it's too low. It's not that problem. Valid. Let's see it.
A máquina está fechada, the machine is on. Yeah, it's just yeah, it's just it's one space.
Can you change it?
Where? Okay. No, not yet. Again. So this one you copy paste.
Yes.
You paste it in front of the one you already write.
Oh.
That's okay, it happens.
Okay,
done.
And you have the.
Yes, I know. Yeah, for you. Yes. Where's the comment? Você abrir a sua máquina virtual, ele vai estar no histórico.
Não dá, pessoal, que a gente entregou. I thought that I was missing this.
Okay, yes, no, it's just a matter of a comment, something that is. Okay.
Yeah, another one. Bandeira espacial.
Esse aqui, ó.
Bandeira espacial.
Ele já vão fazer com uma dele de fato.
Okay,
Something wrong with the pyramid.
Okay, guys, good.
No, I think
All right. No.
Where is the command line?
so that I have something wrong with my water.
Yeah, it's missing one thing here. Let's see if it's open or it's closed.
To this beat.
You close now.
That's a oh, look at you, you know why not so good.
There is a problem with modified each. We're going to find this. Yeah, let's see. Okay, there was. There is a space between.
There's a space.
Yeah. No space.
Where is the gap slash?
I'm always struggling with this. What are you looking for? The
Dots.
oh, wait.
Okay. Yes. Here we go. Okay. And then our initial dots.
N is not the M, of course, right?
It's pretty low. It's really this. No, yeah.
And modify HT.
Okay.
Okay. Publish this file. Yeah. Right. Oh, never.
Ah, you have now
Minus.
Be here, please.
Yeah, without the shift, try the 9. Okay, let's try.
Did I delete something? Because like when I switch my keyboard,
You don't like it.
it's usually here.
It's like tea. That's true. Very, yeah. Yeah. Like that.
Let me do it.
That you asked me how you make it, but I want just yeah, okay, yes. That's like from Africa. Yeah, yeah. Okay. Can you follow the then come back and I once we get this foundation running, we develop this catch up. Okay. Okay, guys, now we are going to launch our virtual machine again, okay?
Rodrigo, chão, por exemplo, que há.
Excelente. Okay. Good. Okay. Let's.
Every time you move, you pull it.
Let's see if the command works. See.
It's not
Okay, so now we have a virtual size of 7 around, but we are using only 10. We have to launch our virtual machine and now say to the system that we can use actually the 70 that we gave it, okay? Launch the machine.
The virtual side of same one as yours because ours had 40. Everything wrong with this place.
The command says that's what increase, that's right? The optical size, tactile size. It's just we can use every storage I have.
Yeah.
Okay.
Thank you. That's practical.
Okay. Now, guys, let's open the terminal. And then I'm going to run a command here that lists to us the space we have available on each disk of our computer. Just to see here that we have one of 50. For now, you see we have 40, a disk of 40. We are using 11, and it says that there is available 27. This is the disk we actually increased. So we are going to run those commands now and say to the Linux partition that it can actually use all the space that we allocated. So we have to run it as administrators inside the machine. So sudo, the command is pro partition, and we are going to type, if I can find. I had it. Okay. Let's just copy and paste this. If you can know how to do it, please tell me after. And here you are going to put a space, okay? It's true because it's the second partition inside this dish. So there is a space before. Press enter. It will ask you the password. And here it says that changing the size of the partitions. But it's not that simple. There's another command. So. The second command is, okay, it says, I can change. Should I proceed? And now you say, yes, you can proceed. Yeah, still good. Now it's attached. That true, that missed, now it's attached, okay? Okay. Are you still with me? Warriors. Okay. Change it. So basically, this type of problem is why we switched it to Docker. But it's not a simple decision because we had the entire code, the work of 10 years, running on virtual machines before with this type of limitations. So we decided to move to a new system, but we have to bring the development of 10 years towards a new one. Our idea is not to use the virtual machines anymore. We have a prototype fully working now on Windows. Perfect, only Docker. Yes, but we have to be able to reproduce this prototype, and that's not mature enough yet. But this will be. Yeah. Basically, in the future, what's going to happen? You have Docker in your machine, you have the file of 7 GB, you run your model.
Okay.
That's perfect. Yes. So the complexity is Yes, but the graphical interface is coming also. Yes. Docker has a graphical interface itself, and you can run.
On the model in Linux distribution directly.
Yeah, if you have a Linux, you don't need virtual machine whatsoever.
So you need to migrate from Windows to Linux.
That's why.
I saw it before. Let's try to. But it works. It's not always like this. Okay. Are we good, everyone? Yes? Okay. Let's see if we have the space that we want. And now you see a size of 67. We are using 11, which is basically the Linux system. And we have 54 available. Now we can run our model. Okay. Dirty work is almost finished. Dirty work is almost finished. Now that partition.
Things good? Yes. Is my computer going well? No.
Yeah.
Now, one question. When you downloaded you took the image of the code, the one that we are actually interested in, that one that finished with .tar.xz. Have you saved it in your computer or inside the virtual machine? You downloaded it inside the virtual machine? Because everything is there. Who downloaded the image of the code inside the virtual machine? You have it inside. Okay. All the others, you have to do one thing with me, okay? Okay. So in the beginning, when we created that shared folder, remember, we are going to mount that volume inside our virtual machine now. There is a command. We will need the name of that folder. Are you with me? It works. So just to remember, I don't remember the name of the mic. If you remember yours, that's okay.
So even here, it could not.
It's serve share, the name of mine. So you need the name of that directory. Okay. We need the name of the directory, serve hyphen share. Yes?
So that's for the one downloaded.
It's Windows. Yes, the heavy one, that one that we passed with the hard disks. It's that one. So we are going to run this command. Sudo out. Just 1 second that I'm loading my command. Yes, you are good. You are good. Yeah, I know. Sudo minus T.
Acho engraçado isso também.
Okay, so this command is basically telling the virtual machine to plug that folder that you shared with it, okay? In my case, the name of the folder is serve share. You have to copy the same name that you put when you created the folder.
Okay. So means that this one is the folder.
This is the one you shared here. The settings here.
So just the last, not the full pass, you just have.
Yeah, when you create, you can give it a name. Remember, usually it takes automatically the base name.
Okay, the base name.
Yes.
Okay.
The name of the base name.
Okay. So just tell me that command and then you share.
I sent to you on where. Let's see, let's run first.
It's step forward. Yes. Because I really told me that I can launch progress. You cannot. I have to go local node and yeah. But no.
Did it work in yours? You haven't tried?
I mean, you could be the same as
It didn't work.
yeah, it's the same.
Okay, it's because you have to create that folder actually. Or let's do it simpler. Okay, just to erase the shared thing. We are creating the point of contact between your computer and the Linux system. They need to communicate, right? So we created it before, but we didn't plug it. Now we have to plug it to the virtual machine. That's the command that do it. In my case, my folder is called a serve-share, okay? Remember when we changed the settings of the machine? Here, we added da nessuna parte. Perché volevo testarlo prima, infatti non è andato bene. Però adesso. Sorry, Peter, coming back. Sure. No? Name of my folder is Rio de Janeiro. That's why the name of my folder is Rio de Janeiro. I have to put yours.
Okay, the folder, the shell.
The shared folder.
No, but I have to download, thank you. No, you remember that, sorry, because.
In your case, you're going to repeat the same command, but instead of serve share, you're going to put some.
Is the Lord of it, so
Okay.
CD wants dash D who was SF sub.
Yes, absolutely. All right. So if I do, for those not used to, this command is to list the content in a folder, ls. Okay. I created basically. I said to Windows to make available everything that is inside this folder in this one. But my folder is empty. If you do the same as me, you should see the stuff that is inside your shared folder. In my case, I'll put my image, the image of the code there now. Sorry, I'll remove this. But I also need to move that. Let's do like this. This way you can see. Could have shared this one, it would be better.
It's not the whole directory, it's only.
Yes, only the base name. Yeah. I don't remember when I shared the folder. But you guys remember yours. Users, administrator.
I think yours was the home page, something like that.
The home page. The home? Yes. No, it says C, administrator.
How are we doing?
We are going to import the image now.
So we are in the same stage on the other one.
Ah, good.
Yeah.
The administrator, it's another user.
If you go so fast, Rodrigo, I don't know if you have, can they follow?
Yes, because here we don't have sudo rise. They do in their machine. Mine, it's more complicated now. We are on the same page here, right? We share the folder. Everyone good? This part, you are still okay. Linux are okay. So have you tried the command ls mnt? Can you see the content of your folder? No? Yes.
Where? In the support.
Yes, that you have to do in the prompt, the command prompt.
The prompt.
Yes.
No, I don't.
I can send you the.
LS. Like we read out which. Hi. It's LS. Do you remember?
And yeah. Oh. Yes, open a chat, so you were.
Yes.
Can you send an email?
Yes. Can I send an email? Yes.
Oh, from this is not your computer.
No, this is the one here. But I cannot share the screen of mine.
No, you cannot.
Try the command, ls.
Yes, but it's stay load.
But because of it.
This
not have it in my computer. It doesn't launch the, but I should.
Why not?
Should. I can copy, but I doesn't. Because here the Gmail account is available.
Mine's
You can send to me like the conference if you want to chat.
Yeah,
It's just a
you
link.
can connect.
Yeah.
Okay, guys, for those online, I'm just sharing a command.
Yeah.
So I said that you sent him a message 4 minutes ago.
Because that command I took from my computer. This one here is
Are you
the,
got Jen?
tell him I sent it in the chat of the conference.
Já para ver que a aula está transmitida.
And he's not connected.
A super está todo mundo.
How do we do?
I don't know. I mean, wait, so many numbers? How can people do that?
Yeah, it's hard to type everything.
I don't think it has a
Yes.
a link in the complimented drive, just that would be faster.
Yes, but I still using this. I'm sending you a picture because they are copy the content of the.
Ah, yeah. Because you're just download.
Sorry.
Download, but you have already done. You can then connect this file to this file. That's I do the file. But those one. Did you download already to the Google Storage?
Okay. Only right way, just needs just in the cards,
Or it means frozen, so it'll be.
I'm sorry, in the yeah, it's a task. Yeah, it's not.
So you need, you know what it means also? Anyway, do you know what red signifies?
Yeah.
Or show me. No.
And now. But minus T. W. You don't remember. You're right, maybe. Okay. Good. Space. All size.
First of all, you're too close, I can see you. Super slow, it's very convincing. So what?
You copy on the street. Okay. Guys, stay where you are. I'm coming back. I just need to share the right folder, the one that has already the image. This way we load it together. Stick with me. Administrator. It's not administrator, it was. It is my test. This one.
You can watch it. But it-
I just shared another folder. Telefone está tudo bem. Obrigado.
Preciosíssimo.
Não, preciosíssimo. Obrigado.
I should.
For now, you don't need to follow me. You're ready to see what I'm doing here. Okay. Compartilhada. Okay, now we are together. Good. So you see the Docker image in the folder you shared, right? Right? Yes? No, you did.
Forget about me.
I am organizing a session with Janice tomorrow or after tomorrow to do it together. So if you want to join, you find the time.
To be here.
You have to be with the class.
Yes.
Yes, you don't have to
I'll
be
get your
here.
contact.
Yeah, someone needs to be here.
Yes. We're gonna have another hand session here.
Yeah. The password is password. Sir. Sir. No, not the sorry. My bad. It's just sir. Serve. But the first one. There is a problem with your sleeping. Não, the command is wrong. The box I said. This one. And one. So just one. Okay. Okay. I'm here. Where are you? I just hold this thing up here. Disappear. Good, but your image is not there. Now I need you in your host system to take that big file, the copy to the 1 of 8 gigabytes, and move it to this directory. Yes, yourself.
That's why we greet each other. We budge each other.
Okay. This one you are going to cut. No, cut it because it's very big. Then go to your sub directory.
If you type in, yes. Let's go. It's the ones. Maybe of you. Parece. I guess. You have to repeat the same command. Oh, wow, no.
We are good. Even too much. Now let's load our model. Docker. Let's check that Docker is actually installed first. Yeah, we should all have Docker inside our virtual machine. Remember those 11 gigabytes was basically Docker. Yes, the image should be in your shared folder here. You see mine is there, Surfshifer, x86, alpha.
O meu ele não está retornando nada quando eu dou esse comando.
But did you put your image in that folder?
I'm going to.
You have
It's
to
already in the folder, in the window, right?
Yes, outside the virtual machine.
Up.
Why are we doing this? Because you don't want to copy this 7 gigabytes of data inside the virtual machine. They are already in your computer. So instead of copying it inside the virtual machine, you create a point of connection.
But sorry. We have to do it before.
No, you can do it after. And this shared folder of yours, you get about.
Oh, you already loaded it.
You downloaded it inside. Okay, that's okay. It's okay. You have it inside. That's okay. I was going to explode it. I'm sorry.
É a mesma coisa que eu tava aqui fazendo. Ele abriu essa parte e aí viu essa aqui. Essa work.
Se você já tem ela dentro da máquina, ok, não tem problema nenhum.
Mas isso daqui já é o image?
Ela tá completa, assim, certo?
É o image isso aqui?
Então só posso.
Então, Billy, it's okay. We can just bring the docker load. Did you run the docker load?
Yes, it's running.
Okay.
Docker load minus I. You say docker load my image, and we give you the commands. Come on, guys, stay with me.
Almost finishing. Then we go to OK. Talk now.
Yes, it's on.
I think I
Mine is loaded. So it should take 4 minutes now, 4 or 5 minutes to load. It's more or less 50 gigabytes. Yes, but consider we have a full one. Our clinic model inside of the other. Inside this model, we have the host company parallel.
Underscore. Okay.
So
This-
you have 50 gigabytes.
It's okay. The lights. It's ready. Yeah. Now it's 1 hour. What's the Rodrigo, agora é 1 hora?
No. So that
No.
no, it should be 4 or 5 minutes. 4 or 5 minutes. So this is your shared place, right? So inside the virtual machine, you do NS. So your NS ability. I don't see the search type an image. That was 8 gigabytes. Already have it. It is possible to run on external like this. So just a second. So here download. You copy it from someone. It was 3.0. You remember where you put it? Okay, yes, it's this one. So it's in Brazil serve. So we have to copy to serve. No, fantastic. No, it's fantastic.
Peaceful, very peaceful.
Very peaceful. Make sure there is enough free space. And that is working properly. So it can be received. Okay. So I have to do the share.
Yeah.
But now I have to clean.
Yeah, we copy it again.
Do you want to copy again? So,
It's waiting.
same problem, let's see.
I'm without glasses. I'm like, still like, is that
You
your?
are, yes.
Spanish lady speaks French.
No. Okay, are you good? It's running.
She downloaded them.
Is it running?
That's okay.
How long do you need to move it? Okay, according to valid notes.
Yeah. That's the only one that. I thought that you copy okay. So.
You have a lot of search.
Yeah.
One won't hurt, you know? One won't hurt.
It's good.
Can we have a coffee break? We have to have.
Yes. Yeah, time because we're loading the bottles.
Okay, you're a bit far ahead now, putting the bottle. Okay, very nice. Let's take a break.
Start the break.
So I have you, before we go.
Yeah.
Now we solve this problem together.
Yeah.
Before I leave, I promise you to make it well.
We make that on pesto.
Some people are something that, like, yours first.
Yeah, I guess we already get people. I said,
So now you see why we ran away.
They don't have enough space in them.
Turn it down. And I agree, it's a bit complicated. That's why you want to check the this is even when we yes, I consider this basic scenes with I think it's a work. In the software, it's still unpredictable. Some of this the size. Yes, machine doesn't allocate the entire size. So you have to do all those series of manipulations. All that is just to say now that I use what okay.
Coffee break, the food is good.
Let's go. So yeah, this is different. Yes, you switch from 425 to 75. Yes, people will use more kids. Okay, I was working in China at the beginning of my days for 2 years, and then I switched to my this is what okay. But SERP is what you're looking for. If the SERP has a friendly interface, it does the dirty bits for you. Once it's set, if you have a Linux, it's really this one command. Docker load, perfect. And then you have another machine. Yes. And then after what you do, you have a JSON file, which is a JavaScript file. If you have something that can actually interpret a JSON file in your computer, you can create your personal graphical interface. You can manage your viscosity, or the diffusivity of my model, what size of the grid, minimum size, maximum size. You will draw your polygon planes, and it runs faster for you the backend. Yes. So that's the principle. Okay. So with Surf, it's more like fast and yes, less complicated. Absolutely. That is the idea.
Going to. You two going.
Yes, coffee. Are we good? It's
So far, so good.
Next week.
Oh, what's this? Also, you're not eating? I found out you choose. Yeah, I've seen, I didn't know what it is. You know that it's like dry food. Yes, I don't know if it's not very cashew, I don't know. Cashew. Yeah, it's like cashew. Oh, yeah, it's my name, it's black.
It started to load in the layers.
Nice. Are we all in the WhatsApp group?
Yes,
please. Yes, what's up?
Yes?
Everyone. Okay, I'm going to share files through WhatsApp.
It's already.
Devi setup.
I thought I was only on side.
Yes.
It's loaded now. YouTube.
No, now they are trying to enlarge this event. So
It's always
Oh, super loud.
For me, it's okay.
Here,
It's too good for you. Yeah.
No, I'm not. It's okay. That's cool. But I'm like this and you're like.
Yeah. I'm like, it's
Prendeva solo 11 nel migliore di giudizio che ho levato sì. Per non avere inizio con queste cose. Se cominciamo a fare il docker noi, e poi manca spazio, devono ricominciare facciamo 70 giga, così siamo tranquilli, non abbiamo bisogno di questo. C'è la solo questo problema.
That should be the same loading right away. Should,
You're going to get there in very few.
okay, so it's working.
Yes, it's working. Yes. No, it's working. Ai, Gabriel.
Parabéns. E começou.
Passou logo depois.
Oh, you loaded.
Yeah.
How much of mine is you loaded? I'm
Say
taking.
easy to make.
Oh, that just went off as usual. This is happening to me. It just goes off. Yeah. I UPN mostly because it's.
I mean, sometimes if I use the VPN, although I'm connected, I have to read up the VPN.
Oh no. Ah, yours is also. I think this one the position is very high. This machine the position is very high, so the position is very fast with. Hey, my anchor friend. My anchor friend from Morocco. Yeah.
Aircon friend.
Yeah.
Didn't the last letter? He didn't like say it loudly.
Aside, do you have anything to do with the EU?
Isso fala então,
Desculpa, não sei o que é para falar.
Eu quis apresentar aqui para esse estudo, né?
Ok. Bom, eu sou José Maurício, eu estudo matemática aplicada na UFRGS, estou fazendo mestrado atualmente e eu quero começar a estudar sobre modelos de dinâmica de fluidos com conservação de matéria. Então, eu estou bem interessado em entender quais são as aplicações práticas do melhor entendimento do comportamento de fluidos em escala doméstica ou global.
falei no início, mas fluidos relacionados com ferro.
Sim, sim. Fluidos é qualquer objeto que está dentro de uma densidade que ele se desloca. Tá? Então é como se você tivesse deslocamento de matéria. Então ele vai sofrer diversas coisas, ele vai se difundir, mesmo que ele ficar parado. Se você tem um fluido que fica parado, você não mexe nele, por exemplo, pensando no gelo, ele vai se derreter. O que isso significa? Ele vai se difundir numa área, ao mesmo tempo que os fluidos eles também se deslocam. This was it?
And so, yeah.
More from this. So I can. It's fine. Muito, but the Wi-Fi we just finished. This is the first time I was not doing this. I use Wi-Fi, it's not appearing anymore. Se você entrou, a gente não vê porque eu tô compartilhando. É possível?
Eu vou ser
Just shut up.
Yeah,
Say.
never mind.
I
I just have yeah. I'm the only one who's everything.
It's the first time. The Wi-Fi is you are.
Okay.
Okay, I see your message, Amina. So you have imported Docker and Surfshifen. So if you have the image, the Surfshifen image already imported on Docker, you can follow with us from now. Okay. I hope you're here. Connection like this, Okay. How far have we reached so far? Okay, so for now, we imported the Surfshifen image. I'm going to show you. Here you go. So this is the output of the Docker load command, and this is all the layers that are related to our model. Okay? And then if you run the Docker images command, you should see it here. So this is our image and the actual size of the image. Because inside this image you have your hydrodynamic model, you have all the layers of pre-processing, you have also the coastline for the entire road, and bathymetry for the entire road. Okay, so that's why 15 gigabytes. When you know what you have inside, doesn't look so much like. Yeah. You have a full baroclinic hydrodynamic model inside your computer, so actually it's 15 gigabytes. It's everything. Ok. Ok, sim. Que a gente vai lançar e a gente deixa o modelo rodando para assistir tudo. Isso.
E aí, já o nosso colega.
If you can ask it nicely, maybe I will.
Jose, could you please put the glass on? They look good.
No.
Water.
We break it. No, I don't think so. Maybe it is the HTML. Yes. So it was no, don't you worry. It was forward path.
Now, as well. Manager, find me. I don't know if it's
No, it's not.
so all the path.
Program files, yes. Program files, you have to go to the Oracle. Storage, box. Big box manager, box manage.
Oh, okay.
Box manage. Okay, then five artists. And we have to be there. No, the Wi-Fi is no, like. I don't see the like I don't know this size. Five G's. Yes. Here it's there. There is another. There are two other commands. It's very hard to decide the virtual machine. So we can. How do you want to do that?
Okay.
I should share it with you.
Yeah, now.
Go part and
Yeah, it's good. I didn't normally do video which part.
but there isn't part. That's why you check.
Okay, so they just copy also me.
Yes. Okay. Okay, guys. So open with me the. Okay. Let me tell you. Surf platform website. If you open it inside the virtual machine, it's better because you can copy paste easier. It's easier. We are going to take the documentation of Surf Scheifen. So this is the official documentation of Surf Scheifen. We can choose the version here. If you are using another version, we are using the 2.1 alpha. So this is the right one. Here there is a small introduction. We describe Surf in general. We describe the Nemo part, the Scheifen part. There are the papers of reference if you want to check. Let's go to the installation, which is what we are doing. Here we have a guide of the installation, and we are working, I remember we are working with Docker. So before I explain to you what is the virtual machine and I explain to you what is the model, right? We are not very interested in the virtual machine part. We just want to use that so that we can run our model. But inside the virtual machine, we are using Docker. What is Docker? Docker is a containerization software, basically that do the work of a virtual machine in a cleaner way. Because we are walking towards a version of the code that does not depend on virtual machines anymore, we are working with Docker even inside the virtual machine. We could have our code spread over our Linux system. But instead of doing it, we are going to create an environment controlled and run our code inside this environment. That's what is called a container. So inside the container, we control everything that it's installed and how it runs. So we don't have problems like the partitioning size that we had to solve for 1 hour here before. Okay, can avoid that type of problem. So in the installation here, the first steps teach you how to use Docker. So you have here recommended installation via Docker. And then you have alternative installation via VirtualBox. So the steps we did are these ones. Here we are good. We are good, we finished this part. So now we are going to follow this part here, the part of Docker. Good, okay? Okay. So you have the website open in your computer. Right. Let's, yeah.
It's already done. The news.
You already did, right? You already have your work directory, all that. Okay, good. So let's start. We are going to create a working directory, first thing. There we are going to run our model, put our configuration files, put the data sets that we are going to download, okay? So let's go, let's do it together. Let's copy the first command here. Okay, what we are doing here, we are basically creating this work directory and exporting it to our bash file. This means that we make it available to our system, so we can access this variable anywhere, anytime. Okay. Are we good? Okay.
Wait. Is something happened here? Like, her screen is.
Oh. Ah, we forgot. Okay, let it be. I think it's suffer a little bit. It's going to survive.
Hopefully.
Hopefully. Yes, let's wait a little bit. Okay.
We're cursed. We are cursed.
Okay, then that command, let's paste it. Okay. Paste. Let's try again. In yours, don't try to use Control V. Try just to paste it normally. Okay. Are we good?
Same here.
So we are just going to see if it worked. We are going to access this variable that we created, surf-dir. All good. We created this directory and we created a variable that holds the name of the path of the directory. There it's where we are going to run our model. So all our results will be there, okay? Let's go back to our guide. Step number 2, download Docker Desktop. Done. We are not working with the desktop version. We are working with the command line version, the one we checked before that it's installed. There we go. So step number 2, okay, very good. Now here it says get and load the Docker, the surf image. We already did. It's what we did before. This option here, you launch the download. That's what this we did before with that craziness of the hard disks. We are doing that. Okay, so we are good. We already loaded the model also. And now we are going to install Surf in the system of the virtual machine. If you didn't have a virtual machine in your case, Linux, you are going to install it in your system. So Surf will be available for you wherever you are in your system, not on a directory or whatever, to be installed in your file system, okay? Which is basically just a command. So this fourth block here is going to install Shyfen. Let's paste. What did you do? We downloaded the file from our repository and we executed that bash script and put it in the bash script of our file system so that it stays available all the time. Okay. It will be for the 3 of. Once we launch the model, we are going to check together.
Does I roll up?
Yeah, cursed.
Mine should have 1.40 gigabyte as well. It's not necessary because mine it's like 370 megabyte.
I'm going to check if it's installed. Okay. See now, we can do Surf Shyfen version, and you should see this. It's okay. It's okay. Everyone has the Surfshark installed. Plug.
Can share plug
And I
adapter
suggest you
with
to
here
open,
or
Chrome
yes, you know can share
so you
with
can
you.
use the browser
The
inside.
adapter and you charge your notebooks and then
Yeah.
Then you type
So you-
Surf platform.
Sure.
So
Thank you.
see, you open it. Yes. If you can paste. Can you paste it? Although we did the thing before.
That's what I.
Yes. Surf platform. Yes, here I don't have it. Surfshark. And you follow the steps. Number one, and once it's installation concerning Docker, you can jump. MNT, yeah. MNT, it's just the name of a directory inside your virtual machine. We made of the directory the point of connection between your host and your guest.
That's the question.
You're running inside the virtual machine. Yeah.
That's very important.
The directory, yes. Okay, now it's the funny part. We are going to start preparing the data to run our simulation. So for this simulation, this presentation, I'm going to probably do tomorrow, the Surfshark presentation. But just to advance some stuff that are important. Yeah, here. Just to advance these things here, what are we doing now? We are going to choose how we are going to force our downscaling experiment. Livia and Professor Luis spoke yesterday a lot about grid, about how we have to pass the large-scale dynamics information from our regional model or global model to our downscaling, right? This is what you're going to do. We are going to force using data from ECMWF for the surface. So all the atmospheric data is coming from ECMWF. That global model that Nadia was speaking this morning, that she spoke about the effort that they did, the first and only global model available for the entire community for freely. We are going to use that, which is this one here, ECMWF global reanalysis. And for the ocean, we are actually using the results from the guys next door. So the output of their simulation we are using to force ours. It's like a double nesting. Okay, they are doing a first downscaling from the global to a larger region. We are taking their data and we are doing a second nesting in the Guanabara Bay, where we are right now. Okay. To avoid download problems, we prepared those data for you beforehand. So we are going to download, extract, and use, plug and play. But if you would set, let me take again my slides here, just to show you one thing. It's better. So here it's the step-by-step, how to choose your bathymetry, how to draw your domain, etc., etc. So this thing I'm going to share with you, this guide. And atmospheric forcing. This is the part that matters for us. This is a piece of the JSON configuration file, that Francesco mentioned this morning, in which instead, the idea of SURF is the following. Instead of learning how to use two hydrodynamic models, that can be very complicated, you have to manage a lot of data. Your model wants that data formatted in a certain way, and sometimes you can lose several months, even years, a year, to learn how to use a model well. You learn how to use a platform, which is SURF, and inside of SURF you have two options already set. So if you learn how to use SURF, you can use unstructured and structured model in the same platform and save a lot of time. That's the idea. Of course, one of the main flags, that's why the R is orange, is relocatable. It's the fact that we can move very quickly, choose regions of the globe, and have a model running in a matter of few time if you don't use VirtualBox. But that is the idea of SURF. It's to make it easy, user-friendly, and facilitate these things like getting important data. That data is actually feeding our model. It won't make physical sense if you don't have that data. But we do not want to lose 3 weeks, 2 weeks setting up our model. So we can do it in 1 hour and a half from this moment now. So let's do it. We are going to download this data now. I'll take back my VirtualBox. And we are going to start this session of the documentation, getting started. It explains to you how to run your first experiment with Surfshark. Okay, you are new to Surfshark, etc., etc. It explains to you how to install, how to check that you have Surfshark actually installed in your system. You already did it. And then this is how you launch a simulation with Surfshark. This is the basic command, but we're going to do it together. Running your first experiment. Here, this is important. Here we have the benchmark, attention please, for the Madagascar study case, which is a benchmark well consolidated for Surfshark. It's the one that we make available to the entire community. We are not interested in executing that one. If you want to do it in the hotel, in the plane, if you have enough battery, you can do it. The one you want to do is the Guanabara Bay. So when you see the steps here, and attention please, run surf with local data. Instead of doing it for the Madagascar study case, we are going to do it for the Guanabara Bay, which is the link, the slide I shared with you on WhatsApp. Okay, clear?
Yes.
So for this part here, please do not copy and paste the commands that you see in the website. Copy and paste the ones that I sent you via WhatsApp.
Okay.
Thank you for the WhatsApp group. So here in the getting started, it explains to run this case study, you have two options. You can either run surf with automated data download, the option that I explained before. You put in that variable the name ECMWF, ERA 5, etc. You create an account in the website of ECMWF. All this is explained in documentation. Surf will take your credentials. We'll ask ECMWF, please, out of your global data, I want just this window here. Can you give it to me? I said, yes, I can give it to you. What are your credentials? Then you give password, user. All this is handled by Surf. Surf downloads only the clip, the region that you are interested in, and take it for you. We did that in the hotel yesterday night. And then we created a tar file, and we are going to download this file. So we use the second option, which is the pseudo first option. We are actually using that data online. It's just that we downloaded it beforehand.
Okay.
Okay. Good, clear?
Yeah.
Let's leave it.
Yeah.
No.
Okay, moving on.
It's okay, it's okay.
I'll get it eventually.
Okay. We are going to follow these steps in order to organize your work. We recommend to create the following directory structure. We're going to do it. Copy this command, please. And we're going to paste it here. And you can also move to our Surfshark directory now. So you see there, those are the two directories you just created. We created a directory to put all our configuration files and one to put all our input datasets. Okay? Now we are going to take that link that I shared with you via WhatsApp. Here it says, download the configuration file for the Madagascar case study. But we are going to download instead the one for the Guanabara Bay case study. This is the slide I shared with you. So we are going to copy this command here. Can I do it? I don't have my own link.
It's the first one, right?
Yes, the first one, the configuration file. Not. Is it good for you? You run the command, you downloaded the file. Do we have the configuration file? I just got mine. Is it good for you? For most of you.
What if she closes that tab? That's and just revise the last from here.
The command, this command is so including the layers that I think you can check it out.
If she shuts it down, does she have to start over from the top?
Okay. Yes, it will stop it. Is it blocked or you can click here machine? It doesn't let you shut down because you have a process running. You can resume. Let's try to try to close it first.
Oh. Maybe I should pause my.
We're back to the real life with colors.
And then everything's like during the
Yeah, let's see if we can restart it. machine. Try again, close this. Keeps the same.
Oh,
Yeah, it would be better.
see? You know what to do?
Just say before I do this. Just to be clear. I really didn't want to lose that. And here, and I come back for this as soon as it's unboxed. Okay, good. All good for the configuration file. Did you find a way to share it inside, run the command inside the virtual machine? Okay.
Really person is lost.
You see that Lydia already finished her experiment?
Of course. Yes.
Okay, why are you running this?
No, like this.
We do Docker images. There you go, you have your image, okay? Now, for the steps we are going to open a browser inside the virtual machine and open the documentation, Surfshark documentation, okay? Yeah, I think you have to find a way to change the disposition of your desktop. It's in the configuration somewhere, view maybe your devices. Do this, open the documentation, okay? We are going to download now the input data sets, which is the second link. Just to read what I wrote here. To optimize our time, we have already downloaded the requested data sets, the required data sets from Copernicus, from ECMWF, the atmosphere data, from GABCO, the bathymetry, and from OpenStreetMap, the coastline. It's basically all the input data set that you need to force our model. And we put it in this file here. I'm downloading the wrong way. Stop. Copy the, you can copy both the comments. It should work. Paste. Okay. Mine is downloading. Should take 2 minutes. Points for you. The input data set.
I'm trying to create some space for it.
Okay. We have a problem of space also. I'm coming. Just check the sequence. Oh, yeah. Just want to change the disposition of the screen. So, screen. I want to take the green screen. But you don't run this one. If you instead is you do this first. Yes, this one, but this one you 50. We have to create it the structure of the.
You should do that.
Yes. We need to change the. Yes, we're going to. Is it if you download, we're going to re-download for us the sheets that you change the configurations. That means you're going to shut down but save these things. So you'll lose. I mean, we don't lose now, we download that. Just for example, we're going to save it and then we change the configuration. Set it. I'll shut it down and then I'll open it again. Yeah, bakery. Let's do this. Okay. Okay, all good for the second data set, for the data sets, for those two commands. Let's see what we did, okay? If you do ls, you list the files inside your configuration directory, you have a new file, config payguanabara. Okay, you see it? Yeah.
They don't know, we have to do it inside the.
You have to do this first. We moved, change directory, before we moved to this directory, and then you do ls configurations. Should be there, the file. This is the file we downloaded with the first command, the first tab we get.
No.
No.
Okay.
Until we solve your problem, if you want to follow with them, so at least you are updated. And then after we come back and we work on that. Okay? Thank you. You have it? I just to save the configuration.
There is space here too, so.
Go to
Let's close virtual box.
what was right? Now it was the
Years.
During the writing of the paper, so
The load, stop reload.
Yeah.
Start? Okay. The same as Mohammed.
no.
The problem was the Docker load, yeah.
There's a problem there.
It's all set. Right. There's no way, so you can check the memory.
Try this. Wait. Come back.
Open another terminal.
You have the flip, right? You're going to solve certain things. Just space.
Okay.
Okay, everyone has the config file. Now you can answer yes, because you are following there and there is a config file.
we have the
We have the config file.
Yeah, do we have?
yes.
Okay, we have it.
Yeah.
Yeah.
Data sets. We have if you do ls datasets, you see a new directory. Yeah. Inside datasets, you should have the following structure: atmosphere, bathymetry, coastline, ocean. It's important that you understand that what is inside atmosphere. Atmosphere. Sorry about that. Again and again, not doing on purpose. So it's important that you understand that what we have here inside atmosphere, it's the ECMWF product.
Data in NetCDF file. Data in NetCDF file.
Yes, in NetCDF file. Okay, this is how ECMWF distributes its data. Okay, so CC for cloud cover. This is humidity, precipitation, sea level pressure, air temperature, wind velocity, on I, wind velocity on X, and then on Y. Okay, so these are the quantities that Shifem needs. Because Shifem needs these quantities, we prepare what Shifem asks. NEMO asks for the same quantities except cloud cover. It doesn't take into account cloud cover, which influences in the radiation computation, okay, the parameterization.
Why so many files for cloud or for precipitation?
Good question. Thank you for reminding me. I'll take my presentation again. And which is we are setting up an experiment. Should be here. Updated one. It is everything. So yes, this is the study case we are setting up now. We are going to run a 6-day simulation on this domain. So we are doing a downscaling experiment with an unstructured grid model in this region. We are going to come back to the details of that. My presentation, I don't think I'll have the time to do today, or so probably tomorrow morning, but it won't remain a black box. For now, we are trying to make this model run so that while the computation takes place, we can talk. But good question. Yes, it shouldn't be a black box. 6-day simulation on that downscale domain. So to run a simulation on that downscale domain, we need this data here. We are starting from, our simulation starts from the 20, but we need day 0 minus 3 of data because we make an initialization 3 days before, because it's the time more or less that the small scale dynamics need to be formed, being fed by the large scale dynamics. So if you say I want to start my simulation from today, Serve automatically takes data from 3 days before and launches your simulation from three days before.
Initial conditions.
Yes, spin up. It's what we call spin up period. That's the period that your model needs to
stimulate the model.
Exactly. To lose that correlation, that influence from the initial conditions.
Okay. Yeah. Sure.
Yeah. So we are starting from the 20. So it's one NetCDF file for each day, for each variable. So from the 17 to the 24 cloud cover, 17 to the 24 humidity, 17, 24 precipitation. So
depends on the simulation. Sometimes you don't need all this data to run, for example, it's dynamic.
For the atmospheric forcing, Shifem wants those variables.
Okay.
Okay, Shifem wants it. Unless you say, I don't care about the wind forcing on my domain. for validation purposes, for tests, one may say, I don't care what the atmospheric, I'm just interested in the ocean. For validation, sometimes you remove all the data from the surface and you excite your boundaries with a sinus function, for instance, so that you see how that sinusoidal excitement is being propagated in your domain. You may be interested in doing that. And you don't want an influence of wind messing up with your test, right? So you can say, I don't care, so ignore it. And then you won't need it. It may be to test what-if scenarios. Also, we had projects that the university asked us to test the behavior change in the shore dynamics of a beach close to my house, 15 minutes away. They wanted to know when the wind comes in this direction, when the wind comes in this direction, or when the wind comes in this direction.
We check the scenarios.
It's in your domain. Yeah, what if scenarios, for instance. So we created artificial wind. We created these netcdf files ourselves, and then we went to surf. We said use offline data, and I gave my artificial data. And then we excited, with
Very nice.
directed wind. Exactly. All this we'll keep discussing also tomorrow.
Also apply when you have a longer period of run.
Yes.
So if I want a 1 month model runs, it has a speed up of 3 days or more.
3 days.
Okay.
Could be 3 days. Yes. If one can choose, I'll show you the configuration file if you want to use less than 3 days. You can do it. But Nadia has a paper about that. Also, she showed that 3 days is basically the minimum period that you need for, it's a compromise, to lose that strong influence of the initial conditions, and also for your scales or your small scales to actually receive that information that is coming from your regional forcing, from your global forcing. So your scales should be formed and lose that dependence. 3 days, more or less. Again, for validation purposes, or one may be interested not to do it for a lesser period. You can choose.
But if I want to resolve the tides, in longer period.
For your case, you may need to make some tests. You may change the value of the parameter and see how it influences. This is one of the tests we wanted to do here in the summer school. But you will have it all set. You may do it in the plane because you already have the input data, right? So what you need to do in the plane is change the value of this parameter, which I'm going to show you now. Run a case, change it again, run another case. You have all the output. You write your post-processing script to see the data, then you can check. And so these are the input data. The atmospheric data that's coming from ECMWF, the ocean data that is coming from Copernicus. Sorry, not Copernicus, from Francesco. Francesco shared it with me via Bluetooth yesterday. But it's the data, the output from their simulation, the one they are running now. In the bathymetry, we have the school product. Like that.
The inputs for OKEANO?
No, you can just plug it to the global model. Yeah. In the value of that variable before. I'll get there. The horizontal grid, bathymetry, coastline, atmospheric forcing, ocean forcing. You see, we are using the output from the simulation of Francesco and your colleagues. That's why we set the value here offline. We are using offline data, offline that we are providing.
For the coastline?
For the coastline also. I clipped the coastline myself, but if you put instead of offline OSM as an option, we already have that data inside surf. So you are going to access that data, clip the box you need, and use it.
The whole world? You have?
Yes, we are going to launch the simulation actually, then we are going to watch the movie.
And what about the grid?
Let's launch the, okay, I want to answer that, hold that. Let's launch the simulation, and then I will keep checking the configuration files. In the guide, we just did this, okay? Take the data, and now we just have to launch the experiment, step number 4. So let's do it. This is the command to remember, and if you forget, come back to the documentation. Please come back. It's good. Let's go together. Surfshifer. Yes. Then we are going to say output directory, where we want to run our simulation. Surfshifer. And let me see, remember the name here, config. Then what is my configuration file? Surfshifer. Configurations, it's the file that we downloaded for, okay? Are we good? Enter. Okay, see? Okay, it's running. Says here the version of the code, where you can get more information. It says where it's saving the results of your simulation. What is the configuration file you used? The number of CPUs you are going to use to run your model. It created a directory tree for your experiment. You're going to check that now. And it loaded the configuration file, and now it's running the step 1 grid generation. After the step 1, echo. So this is the pre-processing step. We prepare the data to then feed our model with that data, and then after we post-process that data. We are going to take a look at the configuration file after, but what you are doing is step number 1, grid generation. And then after, we're going to pass to step number 2, surface boundary conditions, atmospheric forcing. Initial conditions for our model, we are taking it from the simulation of the guys next door. Lateral boundary conditions, the open boundary forcing with their model. River, we don't have here. We didn't add any river runoff, but that's one of the points. Your simulation, Livia, if I remember well, you had some rivers, right? You showed yes, your implementation with ROMs. You had some rivers.
Climatological data.
Okay, climatological data. So you can get the data, prepare it. There is in the documentation, it explains to you step by step.
Fortunately, only climatological data.
Not institution of data.
No.
Yes, okay. It's better than nothing.
Yeah.
You can come, you have a nice session here, how to, in the documentation, in which it explains how to download and put data from internet. So it explains to you what are the data sets available. This is just a variable that you change the name. It explains to you when you go to your config file and you say CMEMS, global, which product you are actually using. You are using reanalysis global product that comes from the Copernicus Marine system. Okay, you are using this product here. Let me show you the right one. The reanalysis product. Global ocean. Reanalysis. So when you go there and you put GMs global, we are using this product here. If we zoom in our region, what Surf is doing in the back end, it's drawing a window here and asking Copernicus to give only this piece of the data so that we can prepare our initial conditions, our boundary conditions to fit our model. Clear?
What about the shadow zone inside of the bay?
We don't have information there. That's a very good question. We have a layer. Okay, now is the moment after answering that question. We have a layer in the treatment of our data. See that? Close your eyes. Spoiler alert. Oh, I didn't do on purpose. So that step that I was speaking before is the input. We are saying to Surf, prepare this data for my model. And then these are the layers that Surf does in the back end. The first thing is there is the sea overlap extrapolation, which is a procedure that takes the information from the ocean and extends it towards the land, covering that part that your model didn't cover. Okay, so if you have holes, let's say you're not using Copernicus data, you're not using CMWF data in which they have a certain quality control before making this product available, but you are using punctual information from observations. You prepare your data set before, but you have some holes. So we are going to perform an extrapolation on the base of that data to cover the region, and then so that you can do the remapping. What we are doing here, we are coming from a structured grid, lower resolution, Copernicus or your observation. And you are remapping it to a non-structured grid. You are making that, you want that information everywhere in our downscale domain, right? So we have some steps that you have to follow before to ensure that you have the coverage of the data, that it's available not only for the entire time period, which was the question of Guido before. Guido, right? Same threat. Okay. So it was Guido or Guido.
In reality, it's Guido.
Guido, sorry. But it's okay.
Yeah.
Yes, about the time coverage, we also want spatial coverage. So that these extrapolations, sea overland, we have it also described in our, guess where? Guess where? Our documentation. So here you can read more if you want to. It's because the model is running, so you can see that the computer is a bit loaded. Input data remapping.
Okay.
You can read a bit about the extrapolation.
How is it calculated and stuff like that?
There is a paper of reference where the procedure was developed. Because it's physics fed extrapolation. So it's not only you are taking data and extending it with whatever method you would like to do, like mirroring or whatever. Okay, you take into account the information, physical information on your solution to do that extrapolation. It's good that you asked that. We can introduce because we are taking the details in the presentation tomorrow. Okay. Let's see how our simulation is doing. We are already in the lateral boundary conditions here. Now I want to show you one thing that is important, and then Livia, after that, if you want, the floor is yours for the movie, because we are going to let the model run for a time.
Do you think we have time?
For the movie.
Janice was checking with the other group if they are running. If they are, maybe we can do it.
Okay, yes. For me, I go as long as I have time, I go. When you need, you can tell me. You can start.
Okay, because we have to leave, all of us, in half an hour. Leave to enter the bus. I don't know. We have.
Yes. Okay, I see. Okay. Okay, then
If we need to, we can
use half an hour.
push push the video for tomorrow.
Okay,
Just, I think we should get this done.
okay,
I think
good,
this is important.
good.
We do.
Let's open a tab here. Our simulation is running, so let's open another tab here. We are in the same directory. Just 1D. Then type this together with me. It's no magic, it's just to see. Are your computers suffering like mine? Here. No, don't type that, please. That's wrong. Wow. Forget about it. So we can do it outside. Never mind. Try outside. Oh yeah, type that, please.
Do we still have the remote people online?
These guys, you can type that.
We do.
Ooh, warriors.
Okay.
Warriors.
Warriors.
No doubt about that.
Yes, you're right.
Actually, Rodrigo, Natalia on remote asked us to share the comments through email. Is that possible?
It's absolutely possible. Yes, I have yes. Ask her to please forgive us. We don't succeed to do it now because the computer is a bit overloaded with the simulation. But as soon as we get control over the thing, we can share it. Okay. Please, in that new tab that you opened, type this command and press enter.
You should throw the glasses.
It looks like it's
That's a reason.
magic, but
That's a reason he's signing here.
that's for one.
The cat.
Can you open a new tab? Yes. And type that command that you see there. Cat. I have to get out of data sets.
Sorry, I have to.
CD. Not yet. Only two. Yeah. Good. Last files. Steady. Okay. First tab is good. Okay. So you are seeing if you type that command and you go up to see the beginning. You type that.
Yeah, I did.
And this is no such.
No certified.
This is what.
The explanation is running.
Yeah. Yeah.
Yes. Yeah. Wow, no. Let me be in the virtual box. Put because you're step one. Okay. Let's look at here.
Okay.
Go step one. That's the output of your grid generation step. So
Anytime I want to.
it's useful for debugging. Also, let's say it crashes right in simulation of what happens. You will have the output of the error.
Okay.
Then you want everything to run smooth, but you don't need to. Here we prepared the data, meaning that it was okay, it was good. But when you start changing parameters and you start running it for yourselves, there will be problems. So this can help you debug.
Okay.
Put us doing here. Step number one is getting bathymetry. It's the information of the bottom of the ocean. If there is simulation of the ice, it has an influence, of course, but in ours it's more important because we are in a shallow area. So at the bay, at the maximum depth of our simulation is 70 meters of the guys. There it's because 500. So, yes, offshore, of course.
Yes, they're working like in continental shelf and stuff like that.
No, they are working in a region that covers from Bahia de Santos Bay up to Cabo Frio.
Okay. Way bigger.
Yes. You are taking the data that we provided, see, and it's doing that first post-processing layer that you saw that's like input. It's taking the data, and then it reformats the data.
It's very sad.
Reformats the data, makes manipulation on new ones. Manipulation number two, manipulation. You're going to see this data tomorrow. You're going to see this. It's actually creating our data. It's actually creating our data. They want by pre-processing. Here we have all the outputs of your pre-processing step. Meshes, mesh output.
You can see how that.
Yeah, you can see how there is a preview of your grid. Okay, that's the grid you created in so in 3 minutes. Sorry, because we had a project recently in the lab that we weren't using search just to get a grid for the Yucatan Peninsula prepares and simulations to run. It was 2 weeks to generate a grid. Of course, there I didn't get it right in the first trial. You take a look at your domain, you see the features of your coastline, the islands, the size of the islands, and the size of your domain.
How do you like, for example?
Yes. And what I was mostly concerned, it wasn't so much the islands here, but I was worried about the inlet of the bay here. You know, it's quite narrow, 1.6 kilometers, and I wanted enough information because the difference of our exercise is to see what are the benefits of an instruction grid model. This morning, Matt and Francisco, they had an interesting discussion about that strait that they had only 1 point. Do you remember? They couldn't resolve. We wanted to be sure that our unstructured grid model actually put enough points to solve what's going on here. Yeah, this small channel, it's narrow inlet. By the way, we are right here. We are here. If you zoom in up, you can see it. Infinite element.
So, Rodrigo, so how the model increase the resolution of the boundaries?
Very good question.
Decrease it.
Always. I don't need to do my presentation. We are going, it's 4 parameters. With 4 parameters, you are generating this grid. We are saying what is the minimum size to apply close to the coast. In this case, you are using 150 meters.
So you need to change values like.
Yes. So of course, when I was setting up the experiment, I made 5-6 tests.
Yeah.
Iteratively, I was changing launches again. But I was launching only the pre-process, only the grid generation step. Yeah, there's the advantage of, let's say, I will start setting up an experiment, but I do not have all the information. I don't know how I'm going to force atmosphere. I don't know how I'm going to do ocean. I just want to start giving a first step for the grid. So you can go in your configuration file.
So tomorrow you will give a presentation.
Yes, I'll give a presentation. And it's good because you already have the practice.
Yeah.
So you know what here we are assigning configuration file, the file that Francesco mentioned. Okay, and tasks. So these are the workflow tasks. See, so enable or disable, decision tasks, etc. Yeah. It's a JSON. It's a JSON, and it's supposed to be user friendly. We have a graphical interface under development. We already have an alpha container of our graphical interface. It's coming soon. And let me just show you quickly what it looks like. It's possible to run this in a Jupyter notebook, for example. It's too heavy to run it in a Jupyter notebook. You depend on the size of your domain, of course, but if you have the model already installed, why would you do it?
No, because I'm used to.
Okay, it's the one you know. Hey, it's a valid point. This is a spoiler for tomorrow. You have a graphical interface that will come that will import the information of this file so that you can come, you see it blurred. You come to the map and you draw your domain, draw your polygon. You can choose your ocean product. Then you pass to the next step. You choose your atmospheric product.
That's amazing.
Yeah, so it's written in JSON because it's web-based, so it's the same. It's the same type of file used to develop this website, for instance, Google is using. So once you import it, either in a platform like that, or even you can write it yourself. You can write a script and create a personal interface of for personal use, for instance, personalized for your case. But while we wait for the graphical interface, we set the configuration file directly. This is what I want to show you now, that few time I have left while our model is running.
Sim, eu tô
For a second.
Yeah, it goes you're right. Oh, the simulation here is almost.
Just keep the river foundation.
River, we don't have rivers in the simulation. Let me show you it's a good point, but I'm going to leave it here, this way we can see the crossword.
Excuse me. I didn't turn off the river. I just ran the example.
I did it for you.
I did it.
It came preset. Okay. Okay, so guys, this is the configuration file. This is actually where, notice that we are running a fully baroclinic model in your computer. And when we launched our simulation, this is all we said. Surfschiffen, where to put the files, and which file to read. So all the relevant information has to come from this file. So the configuration file is very important. You are saying not only which product to use, so all that discussion yesterday that we had, look, a resolution is it matters. If you have a regional product, prefer to use that regional product, right? If you have a regional data available, better, because you are resolving some scales. There are some physics associated to those scales that you are missing on the others. So all that information you are thinking through, and then you are putting it in your JSON configuration file. Let me show you an example. River. We decided not to use rivers, right? So this is here. If you go to the tasks, tasks. There we go. By 7 p.m. we make it. Tasks. Here we go.
Photos. Right? You took photos of everything.
Yeah.
Maybe it will be better if I just do this. It you take a long time just to figure it out.
I'm not doing anything. Yeah. Let's let it breathe. Oh, not at all what I see.
You're not following.
I'm the one who started this discussion first of all.
Come on.
Maybe you can just.
Oh. Okay, let's wait for the simulation to run.
It's hydrodynamic. What is the output that we're looking for?
Okay, good question. Surfshark can give you only the primitive quantities of your governing equations. That means that it gives you two components of velocity, the tracers, temperature and salinity, and sea level.
Surface.
Yes, the water level, the surface. So it gives you only these five quantities. And then if you want to compute vorticity, you do it yourself by taking the altitude of the node and then you compute the gradients and station. There is another way I can show you the configuration file.
Even select. Yeah. Structural.
Yeah, over.
Select.
Out. Sorry. There is another way I can show you.
We don't want to hear about this.
Yes, I'm not doing this. I'm not doing this. Later, please.
Later. Right.
Now I already have a completed.
On Linux, I open this.
Yeah.
Because I was, no, because of the.
Wrong.
Like,
Okay, so in the pre-processing is done. We made We are running the 4th day of simulation out of 6.
How many steps?
There are 7.
Seven.
Here, configuration file. Okay.
It's like an output. This
Input.
okay.
This is telling how to prepare which data.
Okay, it's in the guide.
Yes, which input data is MWF comparing
Okay,
this.
okay.
I want to use my own data, Gemco for the geometry, for the bathymetry.
Perfect.
Yeah, so it's telling all that stuff. And I created it before. So for instance, here you have which model to use. Chiffon. The guys are using Nemo for this option. Configuration level. I want basic configuration level or advanced configuration level. Here I put the advanced because you want to see all the variables. Okay. The name of the experiment. So this is how Surf automatically created that directory. Begonabara, and inside Begonabara created log files, pre-processing, etc., etc. That experiment directory 3 created comes from the name of that variable. And again, where you can find all that information? The documentation. Documentation. All these things are explained in the documentation. I'll show you. So when you come here, start configuration file. Yeah. Imported a basic configuration file and an expert one. And you can browse, see which are the variables. Modeling configuration, Chiffon. Okay. The name of your experiment, the number of processes you're going to use. Here it's using only one. It's running the model in serial mode. We are running with 4 processors. That's why the computer is also software. I think. Here, what are your the parameters related to your grid? Surface boundary conditions, initial conditions, lateral boundary conditions, which product to use, tidal forcing, the one you asked, so you can provide your own forcing in the upcoming version. Yeah. So these are the tasks that you are using. Let's say, for instance, what you're saying before, I don't want to run the entire thing. I don't want to run a simulation. I just want to prepare a grid for now. Yeah. So you come here and you set false, 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 false. And you stop, which when you get the graphical interface, it will be a button, off, 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 and then play. You run, you see, you visualize your grid. I'm happy. I want to continue. So you can switch on the next step and you run again. Surf is going to verify. Although he said true for grid generation, I see that a grid file already exists. So let me jump. I'm not going to overwrite unless you say that you want him to do the procedure again. But if you don't say so, it won't erase your progress from before. It will say, okay, already done, jump, jump, jump. Okay, I go on from where we stopped. Run the next one. If you want to check your date, okay, let me see how is my surface boundary conditions before I go on. You set true, true. You check the output of the surface boundary conditions. Okay, I'm happy, I want to continue. You can switch on your initial conditions. I'm sure of my experiment. I'm sure of what I want to do. It's true for everything. And I press play like we did now. And yeah, you go for it.
Is it
Where to change this? Where to change? Yeah. So here I have the file open. Let's say you run this first experiment and you say, okay, here we had just an example, okay? Here we had 3 spin-up days, the spin-up day value that you're seeing before. I want to see the influence if I use only true. So you go set spin-up days spin up days, you see value equal 3, you set training equal 2, but I want to keep the values of the experiment I run, I want to compare them, right? So you come here to the name of your experiment, which is based on a bar, and you put underscore 2 days, spin up 2 days, so that a surf will create a new directory and put the results of your simulation in that other directory. So this way you don't erase your progress or your previous simulation.
It's already saved.
Yes, and then you go press run again, same command that you did before, and you run a new simulation. So basically in one afternoon, you can, based on the progress you did here, you can run without the visual box part. You can run 3 simulations like this and have base of comparison of three cases, simulation of 7 days, 1 week of simulation, comparing already the influence of a parameter, right? Spin up days, which is quite important. We're speaking about how it impacts the physics in your coastal downscaling model.
If I just want to run a per-drop model, like just the type, is it possible?
Just fight. Because this is a hydrodynamic model. Right? We are feeding Scheifer with tidal information. We are taking into account the effect of tides on the dynamics of our hydrodynamic. So tides, it's an input of this model. It's not an output. It's a forcing parameter. So,
Yes. If I want a per-drop model, can I just turn off all the ES, UV?
I see.
Just to check the simple model.
You can run, Scheifer is a baroclinic model, but you can switch it off and say, okay, I want to run it barotropic. You can do it. Scheifer can do it. SURF doesn't give that option yet, in the sense that you see the model is inside SURF. So you can parameterize SURF as long as we give you the option in the config file. We don't give yet all the information from all the parameters that Scheifer has. When you check the log file of Scheifer, and you're familiar with that, in the initialization you have 120 variables that you can play with. So SURF is also set to run, like Francesco said today, in a certain level of safety, in which the model has been already validated and used a lot for other applications. So a lot of these parameters may be frozen. Parameters so important like turbulence closure, or the non-resolved turbulence of your model is being represented. It's quite important. So those type of stuff, for now we have only one option, the one that is safest.
Yeah. Sometimes they have like, okay, find the.
Yeah, but let's say I don't care. I want to use my own. I want to modify even those. So you can go to the documentation, and here in the how-to section, for instance, how to use how to select the simulation. In the end, you have how to modify the source code. So it teaches you how to enter inside the Docker container, change your code from the inside, and then you make a Docker commit. You create a copy, so that Docker load image that you loaded stays there untouched, and you just create a copy with your changes. So in that case, you would have a container with your barotropic version of Scheifer. Okay. Okay, guys. I think you're all tired. Let's call it a day. Not yet. 1, 2, 3, 4, 5, 6. It's the last day of our simulation. I still cannot. So here, actually, I'm still not following, really following.
I want, like, for example, to skip this,
Yeah,
this and this and work on it in the group.
yes,
So I need to go back to 5.
Yeah.
And like change the transition process.
yes.
How to do so.
And how the model, let's say I want to run only grid. So you are going into the variable, let's do it here because here it's start configuration file.
Define the JSON.
Yeah, so here what you are seeing is the JSON file.
Yeah.
It's general settings, has to create a simulation life cycle. Let's go with that. Here, side. Sorry, I'm the wrong session. Simulation settings.
Sorry, can we wrap things up? This.
Yeah, absolutely. You already did actually. We are.
Yeah, we're gonna continue for tomorrow, the first hour, so you guys can finish things.
Okay.
Hopefully.
No, thank you.
Yeah.
Thank you.
We could accommodate things so you can.
Basically, our simulation is done. We are.
Yeah.
We're finished.
Yes.
Here,
Best team ever.
last day of the simulation.
But Jose did it as well.
You
You did it. Oh, that's.
Yeah, that's everyone say on
Yeah, no, you did it. Yeah.
They try to recompile the new model. I don't know which item.
What happened?
We are in the last day of our simulation.
Running.
Yeah.
Very
used to-
good, Rodrigo.
So
Who
we
is
use the
running?
running.
Who is running?
Everyone.
All of us.
No, no,
Right,
not
right.
all of us.
Was processed completely successful.
We're finished.
How about the others? This is one
We had two problems with one virtual machine that was blocked on the way because of RAM memory.
which we have the same with random.
Yeah, but we are going to get that solved. Vido Pura, sorry, I say one word and I switch it. Him also we are going to solve because I think it's the same problem. We got solved. We just need to move to another disk. Okay. Yes.
Okay.
And yeah.
Okay, like
And-
random.
Yeah. Yes.
Okay.
It's just a matter of display.
One Wino in Mimo, for Mimo, we were able just to start the compilation because it recompiles.
Okay.
It's compiled as copy 0, it compiled and then.
So we were there, but so good. We have to wait. So tomorrow morning, however, we restart at 9 o'clock and we do 1 hour and we conclude. I think it's even kind.
Even better to do because
Maybe not.
because they have the practical part. They don't do that.
We need to.
Yeah, okay, so maybe we separate, you give only to the sharpen because that's fine. And then we go to the other.
And the questions you have, you can also.
Let's go, guys. Great. Let's go.
We finished. Look at that, Peter. Last thing that is really there.
Let's go. Oh, wait.
Hello.
It's from Guido.
Oh, this is from Brandon.
Yeah.
Yeah? From, no, it's from Guido. Guido, you can deliver to him in the, oh, Guido.
Oh, the door.
Oh, let's go.
Yeah, so I'll give you let's switch. But I think it's bigger. It's out, sir.
Yeah.
Thank you, Rodrigo, for your patience.
No, thank you guys, we advanced. Tomorrow we have 1 hour together, so we are going to troubleshoot the problems we had. We are both computers. Okay. Sim, exato. Nice.
We were called after now that we have. But you don't have to go back. You go register and do the simulation with.
Yes, we did.
Try to figure it out.
Yeah.
Beleza. Tá bom. Vai devagar mais. Not working.
Sorry?
Yeah, the bus is downstairs. Oh, can we? Yeah? Get going?
You have to go ahead of us.
My problem is the modify at the very beginning. It was like saying that it was an error with an error.
I would say that it's troubleshoot with ChatGPT.
I need Wi-Fi. That's right. I need Wi-Fi. We have to move this.
Eu queria ter certeza que aqui é ok, que eu consigo salvar.
Você precisa aqui.
Já, here we go. Please, please, please.
Não, não é necessário.
Sorry.
Eu queria ter certeza que o programa que a gente falou que não é um usuário temporário. Não é um usuário temporário, certo?
Não.
Então, ok. É tudo para saber.
Tá.
Só acabar de salvar aqui, a gente está.
Então tá bom. Aí depois eu digo lá que o online. Vocês já deram tchau pro pessoal, né?
Não, ainda não.
Tá.
Vamos lá. See you tomorrow. Todo mundo já fez.
Tá bom. Eu vou parar a gravação aqui. Pode acabar de fazer aqui, depois eu faço aqui. Obrigado você.
See you guys tomorrow. So, see you tomorrow. Bye.
See you tomorrow.
Ma che se ci accompagna stasera?
Sai che lo stesso ragazzo magari.
Andiamo.
Ah,
Andiamo. Devi fare in italiano? Ho fatto dopo.
It's like, why don't you write it?
No, al sud Italia. Dopo io terminando.
Deve essere good. We're starting in the right direction. You will see. In 40 years, you will get more age, and then but now we have to see it. Yeah.
L'aria speracosa. No, lei sono arrivata lei.
Che bellissimo, bellissimo.
Volevo tornare di
Sì.
merito.
No.
No, ma perché si va rimane per un lungo tempo, per un po' di tempo, indeterminato.
La data è difficile. Cioè, è proprio determinato.
Come è andata?
Diciamo ci sta un problema con questa cosa della disco space, Docker Load, hanno fatto il Docker Load
È lunghissimo.
ha preso tipo 20
Come
giorni.
va? C'è risposto qui?
Ancora no. Vediamo.
Ragazzi di internet.
Sì, sa che c'è uno
No,
che è rimasto uno qua però. Ah no, adesso è andato quello. Finita.
È rimasto uno che è già...
Vabbè, allora io faccio così, tanto non sappiamo.
Sì, vediamo se...
Guardatemi in mano.
Sì, certo.
Arrivo su.
Prego.
No, sì. Tu andate Uber o...
Pensavo che non c'è, come si chiama?
Qui sta il driver. C'è scritto mezz'ora. C'è scritto mezz'ora fa che era qua. Non so se c'è qua.
Benissimo, migliore che...
Pensato dove...
Ah, e fa quanto tempo che vive in Italia?
In Italia da un anno.
No, anche io. Però non ho imparato perché io solo lavoro in inglese.
Sì, il CMCC pure. Però ho cominciato a imparare da 6 anni più o meno con la
Da 6 anni.
sì, con la mia moglie.
Prima di vivere in Italia.
Sì, ero in Francia in quel periodo, ho vissuto in Francia 7 anni. Ero in Francia e poi piano piano. Tutto pronto, obrigado. Todo mundo saiu agora também.